And looks like we are finally here. We finally have these first images from the iconic James Webb Telescope, as promised a few months ago, and as we've discussed in some of the previous videos. And here I guess we're going to have to curb our expectations a little bit, mostly because these images are really mostly exciting in terms of the scientific potential. Because honestly, if we compare this image to some of the images from the Hubble telescope, in terms of the visuals, they do look more or less the same. First of all, these images have been processed from the original infrared light to the visual light in order for our eyes to be able to see them. And second of all, these images only took a few hours or maximum a few days to make, whereas in case of Hubble, some of the images that it managed to produce sometimes took weeks and weeks of observations. So in that sense, I don't really blame you if you feel disappointed once you see them in this video. But nevertheless, these images are quite incredible in terms of the scientific potential, and today we're going to be discussing exactly what they are. Hello wonderful person, this is Anton, and today we're going to take our first look and do our first analysis of the first 5 images from the iconic James Webb Telescope that has finally begun its operation and is now collecting a lot of data. And the first image that was produced yesterday, in my opinion, is also the most impressive. Currently this is referred to as the Webb's first deep field. The image that's basically filled with different galaxies. There are actually thousands of galaxies in this image, and some of them have never really been seen before. Something that was only produced after approximately 12.5 hours of observation. And something that would have taken Hubble telescope at least a few weeks to produce something similar. And there's actually quite a lot to say about this image because there's just so much stuff happening here. So there is going to be a separate video about all of this because there are so many discoveries that can be made just by looking at this image. But in a nutshell, what you're looking at is essentially a galactic cluster. It's the cluster that you can sort of see right here, the bright stars. Now, these particular galaxies are roughly around 4.6 billion years old, and this whole chunk right here is so massive that it ends up producing the gravitational lensing effect that's visible as the lens that sort of warps around this area. It becomes a little bit more obvious if you zoom out. And these warped galaxies that you see around the lens, these are essentially some of the most distant objects, at least 13 billion years old. They're actually way behind the central object, and so in this case their light gets dramatically magnified by the gravitational lens. And in this super impressive image, James Webb is able to reveal their extremely bright cores filled with different stars, and even some really distant star clusters along their edges. Now these are some of the youngest star clusters we've ever seen, and that already is super impressive. And remember, it only took 12 hours of observations. But what you might not realize right away is that some of these galaxies are actually mirrored, meaning that the same galaxy appears twice. And some are stretched or are scattered in some other way. And obviously, the redder the object or the more orange the object, the farther away it is from us. So like for example, some of these galaxies that you see right here, especially this one, seem to be super far away. And in this image here, you can kind of see that there is a really interesting spiral galaxy right next to another interesting spiral galaxy that seems to be super far away as well. With I think this right here being one of the farthest objects seen in this image. But in this case, it's not just the visual representation of the image that's important. It's also the various amount of spectra coming from all of these objects, which can then allow scientists that are going to be publishing papers about all of this to figure out what these galaxies are made out of and to basically analyze their physical and their chemical properties. So there are so many more details that are available in this image that are unfortunately invisible to our eyes. But like I mentioned, this image is already so impressive that we actually have to dedicate a separate video to it. But let's move on. The second image looks like this. This is a group of galaxies known as the Stephan's Quintet. 5 different galaxies that look like they're basically dancing around one another, but for the first time seen in incredible detail. And also obviously photobombed by thousands of different galaxies as well. But in this case the detail is just absolutely mind-blowing. These particular collisions seem to be causing quite a lot of new stars to be created, and quite a lot of active regions with a huge amount of star formation indicated by these red areas in the image. And by itself this image is actually pretty large. It's approximately 1/5 of the moon's diameter. And so this is actually a compilation of 1,000 separate images taken over a much longer period of time. Which is also why so much extra detail is visible everywhere here. Once again, so many more different galaxies. With this galaxy known as NGC 7319 also presenting us with a lot of brightness coming from the central region where the scientists believe there is a really massive black hole. possibly around 40 billion masses of the Sun, or about 10,000 times more massive than the one in the center of our own galaxy, Sagittarius A star. But even though there are 5 galaxies and all 5 appear to be dancing around one another, the galaxy on the left, NGC 7320, is actually way closer to us. This galaxy is about 40 million light years away, but everything else is at least 6 times farther away, around 300 million light years. Which once again underlines the importance of knowing the distances in space. Even though these galaxies look like they're all connected, they're not. Only 4 of them are, with the 5th one being in a completely different region. With these 2 galaxies being also very interesting because they seem to be closest together, producing quite a lot of light on the inside as well. Very likely because they're both cannibalizing each other, absorbing each other's mass, which then falls into the black hole and creates all of this brightness. But I'll probably have more to say about this image once more analysis is done and once more data becomes available. Because obviously there's just way too much stuff going on here, so many other galaxies, so many other objects, and so much stuff to discover. So it'll probably take months or even years to actually analyze all of this, discovering what's hiding in these images. And in case you're wondering, here's what the previous Hubble image of all of this looked like. This is from back in 2009. And you might notice slight differences, and that's of course because of the instruments used. Hubble mostly used optical observations, using the same light that our eyes can see. James Webb is an infrared telescope, and so it can actually pierce through a lot more gas and see things that were previously invisible, which is exactly what happened in the next image. The image you see right here, the image of a part of the famous Carina Nebula. The really large nebula that's visible from really far away, and it's actually one of the bigger nebula out there. It's actually so big that in the past, in one of the older videos, I've always used this particular nebula to try to discover our part in the Milky Way galaxy, because it's relatively easy to see it from outside of the Milky Way. You can probably find this video somewhere right there or in the description. But this particular part of the nebula is sometimes referred to as the cosmic cliffs, with the, I guess, height of this cliff being roughly around 7 light years. And in this case, this blue light that you can kind of see coming out of the nebula is the blue ionized gas that's being stripped away from inside the nebula by an extreme radiation on the inside. Mostly from different stars and from a lot of star formation that creates all of this radiation that then ends up stripping the gas. In this case, you can kind of see it extending from pretty much everywhere around the cosmic cliffs. And one of the main reasons why it happens here is because the top of the cliff is in this case the location for a lot of newborn stars that end up creating a lot of stellar wind, which then generates pressure that pushes all of the other gas away, which can then form into other stars or maybe become interstellar gas that ends up circulating in the galaxy. But in this case, they discovered hundreds of brand new stars that they've never seen before inside this iconic region known as NGC 3324. Here's one of the previous images that was available to us from a few years ago. And by zooming in into this image, you can actually see these stars yourselves. There are so many of them that it's just absolutely mind-blowing. I think it will take much longer than just a few months to discover all of the secrets in this image. And that's because this image alone reveals so many new stellar nurseries that nobody knew existed, but even individual stars that are completely hidden in all of the previous pictures. Once again, because it's seeing things in the infrared, and so the infrared light is able to pierce through soundless gas, while the optical light that was used before usually does not go through soundless gas. You can even see some of the protostellar jets that seem to be shooting out of these younger stars, with some of these jets looking remarkably like the ones usually simulated by various supercomputers. So in terms of scientific potential, this image is just mind-blowing. And some of these stars are some of the youngest stars in the galaxy. They appear as red dots in this particular image. And obviously, this being a stellar nursery, it has a lot of these red dots on the inside. And obviously, 4.5 billion years ago, this is kind of what the Sun has gone through as well, and turned from one of these dots into the solar system that we know today. We'll talk more about all of this in some of the future videos. Then we have this other nebula, and that's of course image number 4, the nebula known as the Southern Ring. And if the previous image was showing us the birth of our Sun or the Sun's history, this is showing us the Sun's future. This is a typical nebula created by various Sun-like stars once they go from being a red giant into the white dwarf stage. And in this case there are 2 images because it's taken by 2 different instruments. The near-infrared camera on the left which reveals clouds and clouds of hydrogen emanating from the center, with the blue haze in this case representing ionized gas. These are the leftovers coming from the star's core. And the right image shown as the mid-infrared instrument observations, where in blue you can actually see various types of hydrocarbons, which seem to be clumping to various types of hydrogen and are very likely creating more complex molecules, which by itself creates so many questions already. You might remember that quote from the iconic Carl Sagan, "We are all made out of stardust." This particular image gives this quote even more credibility. This literally showed us that the stardust in this case, from the end of a sun-like star, produces all of the molecules needed for, basically, life somewhere else. Totally mind-blowing, but also so many questions that need answers. In comparison, here's the image from the Hubble telescope. Yeah, definitely not as impressive. And one thing you might notice is that there are actually two stars here, that become even more apparent in the image from the James Webb Telescope. And that's because this particular nebula, located about 2500 light-years away from planet Earth, is the result of a binary system, two very similar stars to our Sun. Actually, kind of more similar to the Alpha Centauri system, one of our closest neighbors. Oh wait, it's not called Alpha Centauri anymore, it's like Righteous Centaurs or something. Anyway, so that system. One of the stars has already become a white dwarf, the other star is still very Sun-like. That's kind of what's happening here as well. Although the star that's become the white dwarf could have been actually up to 8 times the mass of the Sun, and the current mass is obviously unknown. But that second star is also going to create its own nebula sometime in the future, which is something that will happen to the Alpha Centauri as well, and something that will also happen to our own Sun, although Alpha Centauri A is going to do it much sooner. Not anytime soon though, a few billion years. And so definitely quite a lot of new things to discover here as well, especially about the evolution of stars similar to our own Sun. And the last image is not really an image, it's more of a graph, which I think will be the most disappointing image to everyone, because NASA did mention that they might show us an exoplanet. Now, a lot of scientists knew that it's not going to be an image that resembles something like this. It's not going to be an actual planet. None of the telescopes we have right now are capable of producing this. You would need something way larger. But they did get the data coming from one of the exoplanets as it was passing in front of the star, and as its atmosphere interacted with the light coming from the star and reviewed some of the data about the atmosphere itself. And the planet in this case is this planet simulated in Space Engine, discovered back in 2014, known as WASP-96b. A planet, as you can see from the simulation, that's essentially super close to its parent star. But it's also extremely different from planet Earth or from anything else we have in the solar system, even though it's known as a sub-Jupiter. Now it's about 1100 light-years away from us, and a single orbit here takes approximately 3.5 days, but in terms of the actual properties, it's very exotic. It's actually as exotic as it gets. It's about half the mass of Jupiter, it's also approximately 1.2 times larger than Jupiter, and it seems to be much puffier. So essentially it's known as a Puffy planet. We've talked about this in one of the older videos. And so in this case, these were purely scientific observations, allowing the scientists to discover distinct signatures of water. Water in this really hot atmosphere, very likely hotter than Venus, over 500 degrees Celsius. And so during the 6.5-hour observation, the scientists were able to see distinct spectral signs that there was water molecule present in the atmosphere of this planet, which also was the most detailed observation of any atmosphere of any planet ever. Which is really ironic, because only a few years ago there was a study that pretty much determined that it would be impossible for this planet to have any clouds, and that it would probably have a very clear atmosphere. But these new observations do suggest that there are clouds, and they seem to be water clouds. Water clouds that seem to be circulating around the planet. But obviously this is not the first time water clouds or water molecules were discovered around an exoplanet. The most impressive part, of course, is the fact that all of this took 6 hours, only 6 hours, and the fact that these particular molecules were detected when all of the other telescopes failed to find them. Which once again highlights how absolutely ridiculous James Webb is in terms of its observational abilities. But unfortunately no actual image, and so technically I guess NASA released 4 images and 1 graph. Oh hey, I didn't see you there. I was admiring all of these new images released by the James Webb Telescope. and today we're going to be discussing that first image once again, as I promised in the video from yesterday. Today I wanted to do a slightly deeper analysis of this image because there's just so much going on in it. So much that I didn't get to explore in the video before, and so much that it actually is going to take us months to figure out what other secrets are hidden here. The image that NASA currently refers to as the Webb's first deep field, with two instruments, near-infrared on the left and mid-infrared on the right, producing just enough data for an extremely detailed analysis of a lot of different objects in the image, and some of them are kind of mind-blowing. But let's start with the basics. So as you might have heard from the announcement by NASA originally, this image represents a tiny speck, something equivalent to a sand of grain, if you were to extend your hand and to basically look into the night skies. If it's hard for you to visualize, take a tiny grain of sugar or sand, extend your finger, and basically look at it, and that's the size of this image in the night skies. And in this image, we have thousands and thousands of hidden galaxies. And that's of course only after 12.5 hours of observations. We can only imagine what's going to be revealed once the observations extend into weeks, months, or possibly even years. But what exactly are we seeing in this image from two instruments? Well, the most obvious difference here is the bright star you see right here. Notice how it has 6 spikes produced by the telescope in this image, but here it appears as a tiny snowflake. And so by using these diffraction spikes, it becomes possible to see if what you're looking at is a star, like here, or if it's some sort of a distant galactic object, such as the ones here or here. However, if an object is blue but lacks spikes, it could be a galaxy as well. And in the left image, some of the most exciting objects are the green objects. This is in mid-infrared light, and green in this case indicates a mix of hydrocarbons and other chemicals present in these galaxies. So by itself, these two different images allow the scientists to see so many things that our eyes are incapable of seeing, which is why the visual version of this image is actually not particularly useful. It's really when you start analyzing the frequencies of light, what we refer to as spectroscopy, that you start discovering the incredible things in these images. And if you'd like to learn a little bit more about spectroscopy, there's a really good link from NASA in the description below. But in a nutshell, it's a technique that allows us to basically determine what something really far away is made out of, without physically touching it or without physically trying to take samples. This is even used on Mars right now by different rovers by analyzing the spectroscopy of various rock samples by just looking at them with the actual cameras. And one intriguing way where this is used in this image is right here in the gravitational lens created by the Galactic cluster in the middle, the cluster known as SMACS 0723. Now if you look at the optical image, you can kind of see that there are potentially two galaxies that have been distorted by the gravitational lens. Now, is this the same galaxy or are these two different galaxies? Something similar is happening right here. By using the shape itself, it becomes very difficult to interpret the image. Even if you zoom in super close, it's still kind of not clear. As a matter of fact, they kind of look a little bit different. But here's what happens when you look at the spectroscopy of these two galaxies. By analyzing this with one of the instruments on James Webb Telescope, and by looking at the ionized oxygen and atomic hydrogen, it reveals an exactly same spectrum, with hydrogen and oxygen at exactly same levels, or almost exactly same. And more importantly, both of these spectra are redshifted by 9.3 billion years, meaning that these two galaxies are 9.3 billion years old. Now because they have the same spectrum and the same age, it kind of implies that this right here is probably the same galaxy. And so right now that's what the scientists think. They believe that this is basically a mirror image produced by the gravitational lens. And because there are so many different gravitational lenses present in the image, with some of them being warped galaxies and some of them being mirrored galaxies, it shouldn't really come as a surprise that these two are a mirror image. There's actually another video I made a few months ago that explores the idea of these mirrored image galaxies, somewhere right there or in the description below. But I think the most important data from all of this is in this image right here. So the James Webb Telescope, inside of it has approximately 250,000 tiny little doors that can individually open to gather light. And it can actually focus individually on 150 different objects simultaneously. In this case, it focused on 48 galaxies all at the same time, which allowed it to measure the spectra of each of these galaxies and then compare them. And notice how in these spectra we see 3 lines appearing in the same order every time. Hydrogen line and 2 ionized oxygen lines. And by actually seeing where these spectra appear, it becomes possible to calculate the redshift to each of these 48 galaxies, which is exactly what the scientists did, discovering their distance and thus their age in the process. You can kind of see that the farthest galaxy in this image is located in the top left, which I think is this galaxy right here. This is about 13.1 billion years old. And so using James Webb Telescope, the scientists are now able to see the chemical composition of galaxies in the extremely early universe for the first time ever. And because the spectra from these galaxies appear extremely similar to the spectra of the galaxies much closer to us, in basically modern universe, it implies that even back then, the galaxies already seem to possess very similar features. But it also allows us to directly compare the spectra between the ancient galaxies and modern galaxies and possibly discover some differences that might lead to new ideas and new theories. But also obviously measure their temperature, their gas density, and a lot of other chemical composition. And that NASA website I mentioned previously that explains how the spectra works even shows you how these spectral lines are generated. In more physical terms, when the electrons in hydrogen atoms, for example, change their orbitals, so basically they go from one location to the other, they then generally release certain types of photons. These photons always have the same frequency, and there are 4 different ways in which they can do so, which means that they produce 4 different colors, or 4 emission lines. And because this is something that doesn't change with time, we can then use this as a kind of a redshift indicator in order to determine distance to a very far away object somewhere out there. So in this case, if we're looking at the galaxy and all of these hydrogen lines appear in far infrared light as opposed to near infrared light, it means that that particular galaxy is much farther away, and the exact difference in frequency allows us to determine the actual distance based on the current understanding of the expansion of the universe. That by itself is a different topic, because there have been some problems with the idea known as the Hubble tension. You can learn more about this in one of the previous videos. But just the fact that these lines appear to be very similar to the lines we see in the modern universe already has such a profound effect on what we know about the modern physics. In other words, it looks like our theories might be correct after all. It looks like the universe hasn't really changed much in terms of its properties for the past 13 billion years. And it also implies that 700 million years might have been more than enough for a typical galaxy to evolve into a galaxy that we can kind of find in the modern universe. That already has a lot of implications, and also possibly a lot of questions and mysteries behind it. Here's actually the more detailed image of that really distant galaxy, showing us the chemical composition discovered using its spectrum analysis. And so this is actually the first time ever that we've had such an extremely sensitive instrument allowing the scientists to see so much incredible detail from galaxies so extremely far away, which will in theory allow the scientists to reveal the properties of this early gas, telling us exactly how some of the early stars formed and what exactly happened to them afterwards, how they evolved into the modern universe. If you're more of a hands-on person, NASA even has this really cool website that you can find in the description below that sort of allows you to play a mini game here in order to determine how all of this works. So here if we click activate shutters, it will sort of simulate what Telescope does every time it tries to capture the data. And then when we try to capture the spectra, it will show us the data for 4 of these targets. And here we can just basically pick one of these spectra, which will look something like this with the data for redshift, based on the lines right here, the approximate distance based on the current understanding of the Hubble constant, and then we can even compare it to the nearby galaxy just to see how the spectra differ from one another. So for example, here's the spectrum of oxygen. And so in theory, all of this kind of looks like this. You can have 3 very similar spiral galaxies, but the micro-shutter array inside the Webb telescope is actually designed to not just capture the wavelengths of these galaxies, but to accurately tell us about their redshift and even identify the type of the galaxy we're looking at, spiral, elliptical, or irregular, while obviously also determining the age and the distance. And all of this done extremely accurately and extremely fast. And a single image is able to do so to 150 separate objects. Although in this case it was only tested with 48 objects. Nevertheless, quite impressive, and I can only imagine what we're going to be seeing by the end of the year. So this is just the beginning. Hello InfoPerson, this is Anton, and once again we're going to be talking about some of the new revelations in regards to the new images from the James Webb Telescope. The incredible images released by the telescope only a few days ago that have revealed so many new details about the universe we've never seen before. But in this video we're also going to be talking about some other details that have actually been missed previously or have not been talked about much, but also discuss at least one image that was not talked about at all. A very important and a very beautiful image that we're actually going to start with right now. The image that you can find inside the document published on the July 12th with the title that you see on the bottom. Now what exactly is this document about? Well, this is technically what's known as a commissioning report, produced by a huge amount of various people involved in the project, and essentially describing all of the technical details in regards to the operation of the telescope and its ability to perform various tasks as of today. And all of this is based on months of testing that was conducted since the launch of the telescope, with certain tests specifically focusing on very detailed capabilities of this telescope to take certain images and to track certain objects. And one of these tests was specifically designed in order to test how good the telescope was at tracking the moving targets, focusing on things like instabilities, various types of drifts, and performing all kind of motion tracking analysis. And the main reason behind this is because the scientists wanted to know how good this telescope is going to be at tracking various asteroids, various comets, or various other moving objects across the solar system, and how good of an image it can produce at the end. And here they used 9 separate targets, with one being the slowest. Take a guess at what it is. Now you might have already guessed, or you might have seen this before, but here's the result. It was the image of Jupiter. The image of Jupiter we've actually never seen this way. And the image showing us the rings of Jupiter, as well as 3 of its moons, Europa, Phoebe, and Metis, while at the same time even showing us the shadow of one of its moons, Europa, in the image on the left. It's right next to the great red spot that's also visible in this picture. And just like with previous images, the image on the left was taken with the near-infrared camera, with a filter known as f212N that focuses on short wavelengths, and on the right we have the same instrument, but this time focusing on the filter with slightly longer wavelengths, approximately 3.2 micrometers. And interestingly, all of this only took approximately 75 seconds of exposure time, which already implies that these results are sort of mind-blowing and kind of unexpected. And shows the scientists behind this mission that it's definitely possible for the James Webb Telescope to take very beautiful images of various moons and various planets in the solar system, to the point where we actually even see the relatively difficult to see rings around these objects. And that's of course because, unlike Saturn where the rings are very easily visible, the rings of Jupiter and the rings of Neptune and Uranus are very hard to see. And so even though they're somewhere right here in this region and the sunlight should be kind of making them more apparent, I'm actually having trouble finding this in the simulation that I often use. So this is how difficult all of this is in reality, but the telescope was able to see them after 75 seconds. Which is of course great news because it's been previously suggested that we can use rings of Jupiter, Saturn, Uranus and Neptune to definitively study their internal structure. By observing various variations in the rings, it becomes possible to analyze what happens inside these planets through various gravitational anomalies. And even though originally scientists believed that all of this would be extremely difficult and practically unachievable, the James Webb Telescope once again surprised everyone. It was actually expected to be extremely difficult because the light here is quite bright, and so the scattering of the light might affect the science instruments in some very unusual ways, but it was also believed that the guidance sensors on the telescope might not be accurate enough to be able to track planets. The scientists thought that maybe they have to limit themselves to much more distant observations such as stars or different galaxies. But it looks like this time they were wrong, and it's actually kind of lucky that they were wrong. It looks like tracking various objects in the solar system is going to be possible after all, and it works even better than anyone ever thought possible. Which of course also implies that we're probably going to be getting some incredible images of various asteroids, various comets, and a lot of other objects, possibly in the asteroid belt, that we've never really seen before visually. Although they're definitely going to look a lot less detailed simply because Jupiter is just much bigger. And so that's one of these secret images that we weren't really told about. But then there's something else that was recently discovered in one of the images that we already saw. the image from the Southern Ring Nebula. Now, I wanted to actually start right here. This is a video that was recently produced by some of the scientists behind the mission, showing us the kind of a zoomed in version, basically, that sort of helps you realize how extremely far away this nebula is. Now remember, this is thousands of light years away from us, actually specifically just over 2,000 light years away, and so this object is relatively small, but the detail that we've received is incredible. It's going to be appearing on the screen anytime now. And so this unusual nebula, as I've mentioned in the previous video, essentially represents the end of the life for a star extremely similar to our own Sun. As a matter of fact, it is believed that our Sun is probably going to be producing something very similar to this as well. And this nebula, even though it kind of looks flat and as a kind of a oval shape, in 3 dimensions probably looks very, very different. So for example, it could resemble something like this, or more likely, and that's because of the second star present on the inside, it might resemble something like this, a shape resembling number 8. And this is because in the center right there, the 2 stars are creating so much disturbance as they orbit around one another, that they essentially end up releasing all of this material in 2 opposite polar directions. But from our perspective, it looks like this, because we're basically sort of looking at this from, I guess, the top. And also, although these objects are called planetary nebula, they generally have nothing to do with planets. This is just an old name that should have been retired a long time ago. In reality, these are just outer shells of stars as they kind of get older and as they sort of expel their outer shell, creating these beautiful layers. And one of the main reasons why this particular nebula is so extremely bright and actually looks so extremely beautiful is because of that larger bright star that orbits the smaller white dwarf that's responsible for all of this material. Or to be more clear, the star that was very similar to our Sun expelled its outer shell, turning into a white dwarf with all of this gas forming around the star. But then its slightly less massive partner, extremely similar to our Sun as well, because it's still quite bright and produces quite a lot of energy, started to illuminate all of this gas, giving it this beautiful appearance that we see in the night skies. And what's interesting in this case is that you can actually obviously see different types of layers and different shells in a sense, showing us different episodes when the other star lost some of its mass. And so the layers on the outskirts were released much earlier, thousands and thousands of years ago, whereas the layers much closer to the star were very likely emitted less than 1,000 years ago. And so by tracing these layers and examining what's inside of them, it becomes possible to analyze the history of this entire system. And interestingly enough, some of the scientists were actually quite surprised that there were unusual rays of light appearing around the nebula as well, almost as if the starlight from the central star was somehow piercing some of these clouds, with one particular light streak being extremely intriguing. Some scientists at first thought that this is coming from that central star as well, which would by itself create a really interesting mystery. What would possibly create this? And some other scientists thought otherwise. They thought it's actually something entirely different. So there was this unofficial bet going on, and turns out that this is a very interesting detail that everyone missed at first. This is not from the nebula itself at all. This is something that the scientists have rarely seen before. Okay, so definitely doesn't look like it's part of the system. And by zooming in more, it becomes pretty apparent what we're looking at. A very distant galaxy that appears to us completely edge on. Or basically we're looking at it from this perspective right here. Now this by itself is already quite an interesting discovery. A discovery that can definitely allow the scientists to learn more about the distribution of stars in galaxies similar to the Milky Way. But because we have 2 different images of this galaxy from 2 different instruments, it's now going to become possible to analyze the gas in this galaxy just like it's going to be possible to analyze what's happening inside the nebula as well. For example, in the left image, we see a lot of orange clouds formed by hydrogen that was released from the star in the beginning, whereas the blue light that we see is very likely hot ionized gas, and this was from the leftovers of the core of the star. Whereas on the right side, the blue light in this case represents various hydrocarbons, which also kind of seem to form a very similar shape to the image on the left where we see hydrogen. And that's actually because a lot of the hydrocarbons that come from these stars and from these nebula will often interact with hydrogen and actually attach themselves, forming much larger chunks. Now, in that video from before, I've talked about how now the scientists believe that a lot of these hydrocarbons are eventually going to end up on various planets and in various star systems in the future. And so once again, a lot of the stuff that we're made from was actually created in an extremely similar way. This is basically your birth right there, or at least to some extent. I mean, imagine this, but like billions of years ago. And so all of this detail coming from that one single image is already remarkable in so many ways, which is why it's going to be an image that's going to be studied for many years to come. Not so long ago, we've discussed a new discovery of the farthest galaxy in the universe, the galaxy that you're about to see in this video that I'm about to show you, and the galaxy located pretty far away, although it's more accurate to say pretty long time ago, mostly because the distances in this case kind of start to become a little bit irrelevant. As a matter of fact, this particular galaxy is so far away that even its name contains its redshift, which basically defines its distance, or as I mentioned, its age. This galaxy is known as GM-Z11, with Z11 in this case representing the redshift of 11, equivalent to the age when the universe was only about 400 million years old, and the approximate distance to this galaxy being about 32 billion light years. The reason why it's not 13.4 billion is because of the expansion of the universe. We've discussed this in some of the previous videos that might be somewhere in the description. But discovering this galaxy took quite a long time, and quite a lot of analysis and a lot of investigations. Yet now, something happened completely by accident. The scientists found something else, something even farther away, based on the relatively newly released image from the James Webb Telescope. The image that only took a few hours to create, with the data and the image essentially being a kind of a test run, implying, of course, that when the James Webb Telescope starts to observe objects directly and for a long time, we're going to start discovering some incredibly faraway objects, even farther away than anything we've ever seen before. And so I wanted to talk a little bit more about this new paper and the new discovery, which will hopefully highlight how incredibly powerful the James Webb Telescope is compared to any other tool previously used by the scientists. So just as a reminder, this particular image, unofficially referred to as the James Webb Deep Field, only took about 12.5 hours to produce, whereas the Hubble Ultra Deep Field that you see right here took a few months to produce, and the earlier version of the image took at least 10 days. Which means that the James Webb Telescope is able to capture so much more light and see so much farther away in much shorter time than any previous telescope we've had before. Which sort of makes sense, of course, because one of the main purposes for this telescope is to try to discover what the edge of the universe sort of looks like, and to try to discover these super faraway galaxies that are practically invisible in optical light. And so the scientists specifically designed this telescope in order to detect these really faraway galaxies as old as 13.8 billion years, if of course they existed back then. It should still be able to see the light from the really early universe pretty easily once it starts its observations and continuously points the mirrors in the same direction. But as you can see from this image created by NASA, James Webb Telescope essentially covers a really big part of the infrared spectrum, much wider than the Spitzer telescope, and something that the Hubble was never able to do well either. And this is of course super important because a lot of these super ancient objects, the objects that very likely looked extremely bright, produced a lot of different types of starlight, and emitted a lot of different types of energy, by now had their light redshifted so much that all of this visible and even ultraviolet light became extremely redshifted and now appears to us as infrared light, with some light even reaching the microwave spectrum. Which of course means that we're not really able to see these galaxies with a typical telescope such as the Hubble telescope, but James Webb can see them really well. And more specifically, it's able to directly observe that era in the beginning of the universe, often referred to as the Dark Ages, when the stars just started forming, the galaxies started to develop, and the universe was still not particularly transparent. Something that started approximately 375,000 years after the beginning of the Big Bang expansion, but most likely ended within about 1 to 1.1 billion years. And so during that time, things were not particularly clear, and so it's actually kind of difficult to see those things and to study that particular part of the universe. But this telescope makes it slightly easier. As a matter of fact, as this recent study discovered, it makes it a lot easier. And so the scientists behind this paper, with the title "Two Remarkably Luminous Galaxy Candidates at Redshift 11 to 13 Revealed by James Webb Telescope," pretty much tells us exactly what this paper is all about. First of all, it reminds us that we've only discovered one single galaxy at a redshift of over 10, when the universe was approximately 500 million years or younger. And that's of course the GNZ 11 galaxy I previously mentioned. But second of all, they're able to discover not one, but two separate galaxies at ridiculously faraway distances of redshift 11 to even redshift 13, which officially means that this galaxy is no longer the farthest ever found. It's now this tiny blob, which when zoomed in would probably look something like this, with this new galaxy referred to as Glass-Z13. Wait, glass? Why glass? Well, it's actually the name of a survey or the early release data from the infrared imager on top of the James Webb Telescope that released all of this data approximately a month ago, somewhere in mid-June of 2022. And somewhere in this data, the scientists realized that some of the really ancient, really powerful light was actually being absorbed by a lot of the neutral hydrogen that used to exist in the early universe and ended up absorbing a lot of the light that we just cannot see anymore. Nevertheless, by looking at the data from the James Webb, they were able to discover several patches where something was clearly being absorbed, some kind of ancient radiation. And because in this case the emissions that were being absorbed are very likely what's known as the Lyman alpha emissions, or the emissions of hydrogen, usually coming from extremely powerful galaxies that we've seen in a lot of different places. In this case, by using all of this data, it became possible to work out the redshift to these really far away invisible objects, with one of them being a little bit closer to us compared to the previous record holder, and one of them being super far away. The distance in this case would be about 33 billion light years away from us, with the universe being only about 300 million years old. That's actually the time when we think stars only started forming. And so naturally this represents some of the earliest universe we've ever observed. Quite a lot of mysteries here, quite a lot of uncertainties, and quite a lot of potential discoveries. And so far this data has already been confirmed by a separate team of astronomers, so it does seem to be pretty accurate. But I guess more importantly, there's already at least one surprise that seems to be coming from all of this data. In this case, this galaxy appears to be a little bit too massive, at least 1 billion masses of the Sun, possibly even more. And if the mass in this case is correct, it means that these really massive giants could have somehow formed extremely early on and could have already existed when we don't really expect these massive giants to exist. There are also clear signs of what the scientists refer to as the exponential light profile, very likely consistent with this being some kind of a disk galaxy, possibly about 5,000 light years across. Now that would be at least 20 times smaller than the Milky Way galaxy, but the fact that these tiny disks already existed so early on does create a mystery once again. With the mystery being how exactly did they form so early, and how was all of this possible even though the rest of the universe was still in a lot of chaos and we kind of expect things to be a lot more hectic. And so something clearly was driving these galaxies to grow really fast and to turn into disks pretty early on. What exactly happened here and what's guiding them is of course not a question we can answer. Maybe it's dark matter, maybe it's the mysterious cosmic web, maybe something entirely different. Okay, it's only been a few days since I made the last video about the most distant galaxy ever. The galaxy that you see as a tiny red blob in this image, and that the scientists currently refer to as Glass-Z13, with Z13 representing the distance to this galaxy. But now, only a few days later, there's quite a lot of chatter on Twitter, and I sort of joined in on the chatter because there are these two new papers, or possibly even more than two, that might have discovered something even more unusual, something even more extreme, and of course something that was discovered in the new data provided by the wonderful James Webb Telescope. So, hello wonderful person, this is Anton. Today we're going to discuss this absolutely incredible new discovery that's still extremely preliminary, but could fundamentally change the way we see the universe, or at least the way we see the early universe when the early stars and the early galaxies started forming. Because a lot of this new data suggests that we might actually have underestimated the age by which the galaxies have already formed, and also underestimated the age when the early stars formed as well. With these new studies suggesting that many of these stars might have formed much earlier, or maybe there's just something that we don't really understand about the early universe, and something we're going to be learning from the James Webb Telescope. Either way though, these new discoveries are sort of, at least at this point, controversial, and mostly because they sort of contradict a lot of the early predictions and a lot of modern understanding when it comes to the evolution of the universe in general. But I guess before I start, a huge side note. All of this is still very preliminary and has not been peer-reviewed, and more importantly, some of these studies might have actually misread certain galaxies as being more distant than they actually are. In other words, it will probably take a few months before all of this is officially confirmed, or before we can actually understand what's going on here. Anyway, let's start with the basics. So up to about this point, which is just about 1 billion years after the formation of the universe, we kind of have no problems. We understand that at this point, the so-called dark ages were finished, and that's essentially when all of these stars and galaxies in the universe produced so much ultraviolet light that it sort of changed a lot of neutral hydrogen into ionized hydrogen, while at the same time allowing a lot of starlight to go through the universe without being absorbed by anything. But before that, because of the presence of neutral hydrogen, a lot of the starlight and a lot of light coming from various galaxies was essentially absorbed by this neutral hydrogen and to some extent was invisible to us. And because of this, it's sort of referred to as the Dark Ages. Whereas the first light formed approximately 375,000 years after the formation of the universe, and that's the iconic cosmic microwave background that's essentially visible in radio light and represents the first light when the first atoms started forming. But in between these two dates, there is a little bit of uncertainty. Actually, now there is a lot of uncertainty. First of all, it's not entirely understood when the first stars formed and when the stars started forming galaxies, also why they started doing so, and what led them to form more complex structures. A lot of modern ideas suggest that it's maybe something to do with the very mysterious and somewhat difficult to see cosmic web that you see right here. A kind of a structure that seems to be all over the universe and very likely is composed of a lot of gas, some stars, a lot of galaxies, and most likely a lot of dark matter, if of course it exists. But the actual web does exist and has been seen several times. But in order to answer some of these questions, the scientists really wanted to see some of these early galaxies and more importantly discover some of the early stars. They're usually referred to as population 3 stars and essentially represent the stars only made out of hydrogen and helium, nothing else. That's very different from our own sun. Our sun contains quite a lot of different elements on the inside. And that's of course where James Webb comes in. It was supposed to be really good at finding all of this because of its ability to see the infrared light. And infrared light in this case is very important because at these distances, all of the original ultraviolet light from all of these very powerful stars has actually been redshifted into very specific infrared frequencies. And some of these frequencies Hubble was able to detect as well. But because of the frequencies that Hubble could see, its limit was set at approximately 400 million years after the beginning of the universe. Whereas as you can see from this image, Webb can see much farther. In more scientific terms, for the Hubble telescope, the limit was the redshift of 11, or Z of 11. With the galaxy you see right here, known as GNZ11, being the most distant galaxy Hubble has ever discovered. This represents approximately 420 million years after the formation of the universe. For the James Webb Telescope, the NIRCam can extend to approximately 5 microns of infrared light, which represents the age of the universe when it was less than 50 million years old. And a super quick side note, at these super far away distances, using the actual distance, which would be in billions of light years or actually over 30 billion light years, it sort of makes it redundant and somewhat difficult to understand. And so because of this, the scientists usually use the idea of redshift. In one of the previous videos, I showed you this pretty good calculator that allows you to calculate all of this pretty quickly, the redshift calculator by Edward Wright. And so here, by calculating the redshift of 11, we can discover that the universe was only about 419 million years old, and the distance here was about 32.1 billion light years away from us, with the light traveling for 13.3 billion years, which transformed any ultraviolet light into infrared light that we can see with James Webb. And so last week, we talked about this new discovery of the galaxy Glass Z13 with the redshift of 13, which at that point was the most likely record holder. In this case, the redshift of 13 gives us the age of about 330 million years. But these two new papers were able to discover a bunch of more objects, with both of these papers focusing on the iconic first image of the galactic cluster SMACS 0723-73, the image that we were shown a few weeks ago. Here's, by the way, what it looked like with the Hubble telescope. Now, as you might already know, this cluster is also gravitationally lensed. You can obviously see it from the unusual warping of the galaxies. And this lens allows the scientists to see much farther than would be otherwise possible. And so the scientists actually analyzed the raw data from all of the observations of this cluster, with two teams identifying several dozen of new objects, with some potentially being new record holders. And here it's important to highlight the word potentially. These are still very preliminary discoveries and definitely need to be looked at by other scientists. And so in this first paper, the scientists were able to discover 55 highly redshifted galaxies, and 44 of them seem to be entirely new. But more importantly, 6 of them were at the redshift of over 12, and one of them was at the redshift of 16.7, which, if confirmed, would make it the new record holder. This would be a galaxy that's just over 230 million years old, at a distance of almost 35 billion light years away from us. And in order to discover these ancient galaxies, the scientists basically have to look for objects that aren't actually visible at shorter infrared wavelengths, but are visible at certain other wavelengths, which would imply that some of this neutral hydrogen absorbed the ultraviolet light coming from the early stars, but would then allow other light to pass through. And so if they actually discover objects that have these properties, it generally indicates that these must be ancient galaxies that existed during the Dark Ages. Although interestingly enough, a lot of these galaxies discovered so far seem to have a lot of mass in them already, possibly billions of masses of the Sun of material, with a lot of really massive stars on the inside, which was already a surprise because nobody expected to have these very massive galaxies in such early universe. And then we have this second paper that identified 88 candidates, but interestingly enough, at least one of their candidates is at the redshift of 20. And that's when the universe was only 180 million years old, representing the distance of nearly 36 billion light years away from us. Which of course suggests that the stars very likely existed even before that. And that's of course completely unexpected, especially because these are very preliminary observations and very preliminary results. It means that within just a few years we're going to be finding even more records of even more distant objects out there. Although once again, the scientists in this case do suggest that there are only very few of these galaxies that far away, with the majority existing at much lower redshifts of approximately 11. Nevertheless, these are somewhat unexpected and quite remarkable results and discoveries, and I'm sure for the next few months, a lot of scientists are going to be working super hard to try to figure all of this out. But it might actually take up to several years to finally come up with all of the necessary theories in order to explain what happened in this early universe and how these galaxies formed, and also more importantly, figure out when the first stars formed and what actually happened to these early galaxies as they grew in size. At the moment, all of this is a super exciting mystery and nobody really knows any answers just yet. Hello wonderful person, this is Anton, and when it comes to galaxies, there are only a few that are actually iconic, and one of them is right here. This is known as the Cartwheel galaxy. The galaxy that you can see right here in the picture from Hubble, and a galaxy that I've recently mentioned in one of the videos about ring galaxies, because this is actually one of the most iconic ring galaxies out there, and allowed the scientists back in the day to essentially explain how we today believe a lot of ring galaxies form. You can actually learn a little bit more about this in this other video that should be in the description below. But very recently, the scientists announced that they released new pictures and have conducted new observations of the region where this galaxy is located by using the infrared instruments on the James Webb. In the process, seeing this galaxy in new light and providing some new observations and new explanations for what we now believe happened here a few 100 million years ago. And so let's discuss these new pictures and these new observations in more detail, and talk a little bit more about this iconic galaxy that sort of forms one of the most beautiful formations out there in the night skies, even though technically you would need a very powerful telescope to actually see this. And let's actually start right here. This is a simulation of this galaxy in Space Engine, and you can sort of see that it's not an only single galaxy here. there are at least 3 galaxies sort of connected to one another gravitationally, although as some of the X-ray observations revealed, there are potentially a lot more here, with most simply being relatively difficult to see because of the distances. And originally, this galaxy was discovered by Franz Zwicky, the Swiss astronomer famous for coining the term dark matter. He was essentially the first to discover these unusual phenomena that he could not explain and called them dark matter because it was some kind of invisible matter that nobody could see. But in 1941, he also discovered another mystery he could not explain. He actually considered it to be the most complicated structure that still had no explanation and could not be explained with simple stellar dynamics. Here we had 4 physically connected galaxies, spiral galaxies, with 3 being relatively close and 1 being slightly farther away. You can actually sort of see the 4th one in the top right corner. And so these galaxies presented early astronomers with a new mystery. How exactly did they acquire these unusual shapes? And at a distance of just under 500 million light years away from us, or approximately 250 times as far away as the nearby Andromeda galaxy, it was relatively difficult for the early astronomers to see the detail required to explain what happened here. But because of the recent detailed observations in the X-rays, visual light and infrared light, the scientists are pretty certain they know what happened here. This is a result of one of many different types of galactic collisions, in this case between relatively large and relatively massive galaxies. In this case, the Cartwheel galaxy is just a little bit smaller and less massive than the Andromeda at roughly around 145,000 light years across. Although its size might have actually increased because of the collision with one of the galaxies near it, very likely the one that you see in the top left. But obviously the question is, why exactly does it have such a strange shape? Normally when we see galactic collisions, they sort of produce more irregular shapes and sometimes result in the formation of what's known as the elliptical galaxy, which might then lead to a formation of a spiral galaxy. As a matter of fact, a lot of galactic collisions look somewhat different to begin with. Well, as I've discussed in that previous video about the ring galaxy formations, sometimes when the orientation between colliding galaxies is just right, one of the galaxies might end up shooting through the other galaxy in such a way that it essentially forms a bunch of ripples around it, with the ripples in this case being represented by the hydrogen gas. And a lot of these ripples will then produce a lot of higher density regions in a kind of a circular formation, which will then initiate star formation, but in this case in a circle around the galaxy. Although because there are other galaxies involved in this case, the circle is not really perfect like in other ring galaxies, and is thus a little bit distorted. In this case, we actually have 2 different rings in this galaxy, very likely from multiple collisions, with the outer ring having a velocity of about 270 km per second as it moves around the galaxy. And as you can see from the X-ray observations, there are quite a lot of very active regions, very likely producing a lot of black holes and neutron stars, because of an extremely active formation of really massive stars. As a matter of fact, very recently, just a year ago, the scientists detected a supernova in this region. Here's what it sort of looked like when it happened just a few months ago from when I'm making this video. As you can see, it was pretty powerful and quite bright. But what makes this galaxy unique and somewhat interesting is not really the rings, as much as the structure between the rings, the Cartwheel spokes. And that of course makes this galaxy very complicated and extremely intriguing. These unusual spokes even seem to connect the outer ring with the inner ring, and this is not something we often see around galaxies. As a matter of fact, it's the only galaxy known to us that seems to possess such strong formations. But in this case, these formations very likely represent a bunch of reforming spiral arms that are slowly being developed after the collision that very likely happened 200 to 300 million years ago. Which of course implies that back in the days this was probably a typical spiral galaxy, with typical spiral arms. The arms that were destroyed during a major collision. However, following this collision, some of the previous dynamic forces started to slowly rebuild these arms and created these spokes we see connecting the 2 rings, with the new images from the James Webb Telescope revealing new details about all of the star formation and about these spokes. So first of all, this image right here, taken with the near-infrared instrument, definitively shows us that this existing structure on the inside seems to be slowly disintegrating and is actually reforming a spiral galaxy. If you look at this in more detail in one of the links in the description below, you can actually see this really bright core containing huge amounts of hot dust that seems to contain a lot of giant star clusters that were previously invisible to us. Whereas, as before, we can see a lot of young, active stars on the outskirts, with the ring that very likely expanded for the past 400 million years, still forcing a lot of new stars to form because of the higher presence of dust in this area. And a lot of detail produced by this instrument shows us quite a lot of clumpy areas associated with younger star formation, as opposed to older stars that generally produce much smoother areas. As a matter of fact, every blue dot you see in this image represents some kind of a star or a small pocket of star formation. And here we can actually see that the star formation only happens in certain regions, and mostly along the spokes or along the outer ring. But in order to learn even more detail about this galaxy, the scientists looked at this using MIRI, or the mid-infrared instrument. The instrument that produced a very different image, showing us completely different detail. This here actually shows us mostly hydrocarbons and a lot of silicate dust, or the stuff we usually find on various planets and various rocky objects. And so here we can actually see the regions that are extremely rich in a lot of these elements, with once again mostly the rings and the spokes having most of these materials. The rest of the galaxy is pretty much empty. But more importantly, this image right here definitively solves the mystery of this being a transitionary galaxy. A galaxy that's slowly turning from a ring galaxy into a typical spiral galaxy like the Milky Way. And more importantly, points at that other neighbor that you can see in the top left as the most likely culprit that caused all of these rings to form. The satellite galaxy that you see right here, that's sometimes referred to as G2. And so this whole structure will very likely disintegrate completely in the next few hundreds of millions of years, with a lot of the gas and the stars on the outskirts most likely making their way toward the center, which some of them already seem to have started doing, and eventually reforming some kind of a spiral galaxy with very prominent spiral arms, potentially resembling the galaxy that you see right here known as the Pinwheel Galaxy. And altogether, these observations more or less solve the mystery of many different ring galaxies out there, and kind of show us what happens when certain galaxies receive a collision right in the middle, and very likely from a very specific perpendicular direction. Although in this case, because as you can see the ring is not perfect, something else might have disturbed the shape afterwards. But I guess more interestingly, even though the original spiral was destroyed, this galaxy is now reforming a completely new spiral, and is actively forming new stars that will probably be responsible for the new arms in the next few hundreds of millions of years, making this one of the more unique galaxies out there, and a galaxy that sort of solved a lot of mysteries when it comes to the galactic collisions and when it comes to formations of galaxies. Our galaxy is filled with a lot of mysterious and very intriguing stars, but some of the most intriguing ones are also some of the most extreme. For example, this type of a star is known as a Wolf-Rayet star, named after two astronomers, Wolf and Rayet, who originally discovered them back in the late 1800s. And although we've discussed these stars in some of the previous videos, in this video I actually wanted to discuss the upcoming study that's going to involve James Webb Telescope that potentially has a chance to resolve a lot of mysteries about these stars and how these stars help the galaxy evolve and help the universe create new important materials. And so today we're actually going to be discussing these stars once again, but more specifically starting with this image I found completely by accident on Reddit. And this is actually why I wanted to discuss these stars, because they create these incredible images and because they create a lot of really unusual effects out there in the universe. So this Reddit user right here recently posted this processed image from the James Webb Telescope that showed us this. This is technically the first image from the James Webb Telescope showing us a very famous Wolf-Rayet star, and the image by itself is incredible for several different reasons. First of all, like a lot of other Wolf-Rayet stars and their vicinity, this one really stands out. It's the brightest object visible to us. And this is one of the defining features of these unusual stars. They're generally some of the hottest and the brightest stars in the vicinity, with a lot of them being visible and present right here in the iconic Tarantula Nebula, the nebula located in a nearby Large Magellanic Cloud. And the most extreme star of them all is the distant star known as R136A1. That's essentially the most massive star we've ever discovered. It's over 300 masses of the Sun and would be a really huge massive object compared to our Sun that you see right here in orange. But before I tell you a little bit more about this image I previously showed you, so what exactly are these stars and how would you define one if you were to look at it in the night skies? Well, the original definition was really in regards to their spectrum, or essentially the type of gas they possess and the type of emissions they produce. Normally they have a very unusual spectrum that doesn't seem to have any hydrogen in it, but does have a lot of ionized helium, but also ionized nitrogen and ionized carbon. And generally this type of ionization can really only happen in some of the most extreme conditions, usually very high temperature. And so by having these particular emissions, it means that these stars are basically emitting so many different ionized particles of things that are not hydrogen. Mostly because, in many cases, the hydrogen that was present here was basically expelled and created a nebula around the star. But later on, the scientists studying these objects realized that they do come with different properties, and some of them do actually emit hydrogen as well. And so today there are actually several different classifications of these Wolf-Rayet stars, with many of them producing different types of spectra. But they're also believed to be a natural stage in the evolution of extremely massive stars. And depending on the total mass of the initial star, they'll probably end up producing slightly different emissions later on. So basically this is just one of the stages as the star advances through its age and then changes into something else. But unlike a typical star, like for example our Sun, in this case a typical Wolf-Rayet star, because of the ridiculously powerful emissions, will generally have a much higher amount of heavy elements present on its surface and also extremely high stellar winds. And in this case, if our Sun was some kind of a faucet dripping water in terms of the energy produced, a typical Wolf-Rayet star would be this very powerful fountain emitting so much water all at once. Although in this case, instead of water, we're talking about a lot of elements present in typical stars. And all of this creates these ridiculously high temperatures, sometimes reaching 200,000 Kelvin, making them the hottest stars in the universe. And most of this energy comes from the fusion of helium or heavier elements inside the core. The hydrogen is no longer being fused. Although in other cases, certain types of Wolf-Rayet stars can actually be on the opposite side. They could be extremely young stars, still fusing hydrogen, but also producing tremendously powerful emissions. But that's more of an exception than the rule. The classical version of the Wolf-Rayet star is a star that's basically reaching the final moments of its very powerful life. These stars also generally produce tremendous amounts of ultraviolet light, which for the James Webb Telescope means that it can technically see some of them possibly forming in the beginning of the universe, which is why so many scientists want to study these objects with this incredible infrared telescope. And by the way, these stars are so bright that at least two of them are actually visible in the night skies without the use of any telescopes or any other devices. You can see this one right here, and also this one right here, with the naked eye, despite the fact that this star is at least 1,000 light years away from us. And as of today, at least 500 such stars are known to us in the Milky Way galaxy, but less than 1,000 of these stars in the local group of galaxies. For example, there are approximately 160 of them in the Magellanic Clouds, and about 150 of them in the Andromeda Galaxy. But they're very common in starburst galaxies, and they're also very common in specific types of galaxies known as Wolf-Rayet galaxies. There should be a bunch of videos in the description that explain all of this in more detail. But back to this original image and the Wolf-Rayet known as WR140. Here's a slightly older image with slightly less quality, and here's that newer image from the James Webb Telescope processed by the user on Reddit. And one thing you can kind of ignore here are the spikes. That's essentially the result of the design of the James Webb Telescope. But what about these unusual wavy lines? Well, initially it might appear as some kind of a lens reflection or some kind of a processing artifact. It's not though. These features are real and they exist around the star. They're visible slightly differently in this previous image I showed you. And these features tell us a little bit more about the star we're looking at and how it very likely formed. So first of all, this is once again a relatively bright Wolf-Rayet star, but it's part of what's known as a spectroscopic binary. which often represent a single star because of the brightness, but you can actually tell that there are two stars here because of unusual effects. For example, unusual redshifts and blue shifts, unusual wobbles in the orbit, or in this case, unusual wavy formations around the star. Now the main star here is what's known as a O-type star. These are some of the most massive and brightest stars in the universe that are still burning hydrogen. And the Wolf-Rayet itself is the smaller partner. In this case it's slightly less massive, but it's a lot hotter and produces a lot more emissions. Although overall it seems to be also less bright as well. But because these two stars seem to orbit around one another, approaching each other as close as 1.3 astronomical units and moving away as far as 24 astronomical units, they tend to produce very unusual effects every 7.94 years. And so when the two stars approach each other really closely, they create a lot of radiation-driven stellar winds. Super powerful emissions which only happen every 7.9 years. Generally this is actually known as the colliding wind binary, and in this case WR140 is one of the most well-known such binaries. And so each of these rings that you see here are technically little spheres that represent much higher concentration of stellar wind, released 7.94 years apart, with approximately 20 shells visible to us, and very likely more discovered in the future as James Webb provides us with even more detail. But based on these observations, it looks like this whole nebula was created approximately 160 years ago, mostly because there are 20 shells visible here. But during this close approach right here, these stars also tend to emit a lot more infrared radiation, mostly because they tend to release a lot of dust at the same time. And so all of this would be actually very easily visible to the James Webb Telescope, which is exactly why this particular study wants to investigate this in more detail by observing the star for approximately 20 hours. With the main idea here being the comparison with various simulations created by the scientists behind the study. But today it's also believed that certain types of massive binary systems can actually develop into Wolf-Rayet stars over time. In other words, it presents us with a kind of a third scenario for the formation of these unusual objects. And this can maybe happen when one of the stars strips its partner of a huge amount of mass, mostly due to the stellar wind produced when these objects approach each other. And so in this case, this could also be one of these stars. It could be a star that was basically produced because of the interaction between its partner and itself, with the partner causing the star to essentially lose its outer shell and to turn into a Wolf-Rayet star. And about 1/5 of all of the Wolf-Rayet stars found in our own galaxy could have been actually created this way. But because a lot of them will also be covered by a lot of dust from the hydrogen released from these stars, it's also generally very difficult to observe what's happening on the inside. But not for the James Webb Telescope that can kind of see through all of this and even produce the beautiful detail that's visible in the image, even though the star is over 6,000 light years away from us. All of the first images from the James Webb Telescope so far have revealed so much new information about the early universe. But naturally, they've also created a lot of buzz with certain articles making a lot of claims that are basically not true. And one article in particular has actually been trending on Twitter with several people asking me for a comment about this. Actually, it was the Australian YouTuber Dave Jones, who I also watch once in a while, and he asked both me and Dr. Becky for an opinion on this relatively recent article that's sort of been trending. The article that says the Big Bang didn't happen. And the article that essentially implies that all of these new observations from the James Webb confirm an idea from the 90s that this particular writer behind this article had, with the idea in this case being that the Big Bang never happened. And so in this video I wanted to kind of talk about this a little bit without being too critical or maybe too judgmental, but essentially focusing on the facts. And to start, I actually wanted to briefly talk about where I think Eric Lerner, the article author, got things wrong initially, or at least where I think all of this started. It's really from articles like this that I've discussed in one of the previous videos, where the scientists behind this paper gave some of these articles somewhat unfortunate titles and also made a few comments inside the articles, essentially indicating that they were just shocked by all of the new discoveries coming from the James Webb. In this particular case, the paper starts with the word panic, as if the scientists are panicking about new discoveries. But that's actually not at all the case, and if you do read the article, you'll realize that it's basically not at all what the scientists are saying. They're not saying that the new images are breaking physics in any way, or that we're discovering something that was completely unexpected. They're just saying that we're discovering things that were just a little bit different from what we expected. But more importantly, we're discovering a lot of evidence that does suggest Big Bang indeed happened, and happened just as predicted by various studies. So here it's really important to understand that pretty much most of the analysis so far and all of the data coming out is mostly from these early publications on sites like Archive and from a lot of chatter on Twitter. And so because all of this is really coming in super quickly and there's just not enough time to confirm and analyze everything, it's naturally kind of easy to start misinterpreting some of the results or some of the discoveries, especially if the title is maybe somewhat misleading. As a matter of fact, one of the quotes used in the article to present their point is from this astronomer, Dr. Kirkpatrick, who in one of the studies mentioned that right now I find myself lying awake at 3 in the morning and wondering if everything I've done is wrong. This was from one of the papers I discussed in one of the previous videos, but she's not saying that the Big Bang did not happen or that our cosmology is completely wrong. She's essentially only questioning the early evolution of the universe because the actual observations, as I mentioned in the video before, seem to be slightly different from what the scientists expected. But claiming that the Big Bang never happened because of that one quote is a huge disservice to the scientific community. But instead of focusing on that article that I personally did not find very interesting, and that is kind of wrong to be honest, I actually wanted to focus on the facts that we know about the Big Bang and why we now believe even more that it very likely did happen. And here we have to start with a bit of a history. As a matter of fact, the history here is super interesting. Have you ever wondered if anyone was even smarter than Einstein? Have you ever wondered if anyone has ever proven him wrong? Well, yes, the answer is yes. And it's a person in this picture. Can you guess which one? It's the priest in the middle. The Belgian Catholic priest that back in the early 20s started to explore the idea of cosmology, reaching some of the conclusions before anyone else, with some of them becoming groundbreaking over time. Actually, before Lemaitre there was another really important discovery a few years prior. In 1923, Edwin Hubble confirmed that various spiral nebulae that were actually detected by various scientists were not within the Milky Way. They actually were various galaxies across the universe, with many of them really far away. This was the beginning of the idea of the universe, and if you'd like to learn more about this, check out one of the previous videos in the description or maybe somewhere right there. And within just a few years after this announcement, Lemaitre started to observe an interesting pattern in a lot of these new observations. Just as the Hubble's original observations, he realized that it seems that a lot of different galaxies, the farther away they are, the more they expand. But then mathematically, he was able to work out that if the universe was actually growing in size, from a much smaller point in the past, all of these observations from Hubble would suddenly make sense. In the process also calculating some of the first values for what we now call Hubble constant, although more officially it's known as the Hubble-Lemaitre constant. He then sent all of his observations and calculations to Einstein, who unfortunately dismissed them completely, stating that your calculations are correct, but your physics is abominable. So yeah, this guy was quite a character. But then within just a few years, this guy was proven wrong. The guy in the middle was proven correct. And Einstein had to concede because Lemaitre has just discovered the idea behind Big Bang. But it became pretty clear that the universe was growing in size. Several other scientists joined in and started to realize something else. For example, George Gamow that you see right here realized that it wasn't just about the mass, it was also about the radiation and the photons. And specifically, as the universe grew in size, the density of the photons and the energy would increase. But if you were to go back in time, it would increase to the point where the universe was very likely extremely hot. So hot, as a matter of fact, that a lot of the early atoms would very likely be ionized, leaving behind a kind of a radiation sign that should still be visible even today. In other words, he predicted something that was discovered decades later. He predicted the cosmic microwave background radiation. And honestly, there is absolutely no way to explain this without the Big Bang. We see this radiation coming from every direction. As a matter of fact, part of the static on the old TVs that we used to use with antenna was the result of cosmic microwave background radiation interacting with the TV's antenna. So the CMB is definitely real. But explaining this without the expansion of the universe from much smaller state is practically impossible. Several scientists have tried to do so, but all of their ideas have so far been disproven because they don't really explain everything. This, however, does. CMB is a very important part of the expanding universe. And the ideas from the Big Bang suggest that at some point the universe was just extremely hot and no atoms could even exist here. More importantly, if you were to try to trace back all of this based on the modern observations, as you can see being done right here in one of the papers you can find in the description, you'll discover that it all seems to kind of start around 13.8 billion years ago. And that of course implies that, well, there was some kind of a beginning for all of this. So is that the Big Bang? Well, the answer to that is a little bit tricky. In the past, that's what the scientists referred to as the Big Bang. Actually, okay, a little bit incorrect. The term Big Bang was proposed by Fred Hoyle, a British astronomer that was actually a proponent of a completely different idea. As a matter of fact, he was one of the earliest critics of the Big Bang theory. And so he was actually arguing for the steady-state model of the universe that tries to suggest that the universe is the same everywhere, no matter where you go, no matter when you go. But the modern observations suggest otherwise. More importantly, this does not explain where CMB came from at all. But during his arguments, he basically said that the universe did not just start with a Big Bang. And that was the birth of this particular term. But more importantly to the topic at hand, we have so much more proof of the idea of the Big Bang from all of the observations from modern telescopes, including Hubble and now James Webb. So first of all, as I've discussed in one of the previous videos, some of the earlier observations from the Hubble telescope determined that the universe was indeed much warmer billions of years ago. There should be a video about this somewhere right there, or maybe in the description. This by itself definitely suggests that the universe cooled down over time, and the only possible explanation for this is that, well, the universe expanded, decreasing the density of the energy and thus decreasing the temperature. But more importantly, the observations from the James Webb have now started to also uncover these very distant galaxies around the same time we believe galaxies started forming, but in this case not as developed and more importantly much smaller in size. And that kind of aligns with all of the ideas behind the growth of the universe and behind the Big Bang. Oh wait, I forgot to mention something. Okay, so today there's a bit of a misconception with what Big Bang actually means. It doesn't mean that the universe just exploded 13.8 billion years ago, creating everything we have. Today, this whole thing is called the Big Bang, the entire expansion of the universe in the last 13.77 billion years. That's what the scientists actually refer to when they talk about Big Bang, not just that one point somewhere right there in the beginning. And that's of course really important to understand, because by saying that Big Bang did not happen or doesn't exist, that person is essentially saying that the expansion of the universe is not happening either. The universe is not growing, the galaxies are not moving apart, and the universe is the same everywhere no matter where you go. Well, it doesn't seem to be the case based on the observations, and especially the observations from the James Webb. These galaxies are moving away from us, and really fast. Tens and even hundreds of thousands of kilometers per second. That's why they're so redshifted. On top of this, every single one of these observations from the James Webb so far has actually showed us that the galaxies were much less evolved and much smaller in size before, with a lot of large-scale structures only being developing and not really complete yet. Actually, most of this evidence comes from the Hubble telescope, but even the James Webb seems to be showing the same. And by design, the James Webb is really only meant to observe certain parts of the universe, and specifically it was designed to look back at the time when the universe was only about 50 million years old, or maybe slightly younger. It was never really meant to look farther than that. And so it's not actually going to be seeing some of the first moments when, for example, the cosmic microwave background was created, because it's not designed to see that. But from what it has seen so far, and all of these distant galaxies discovered, two things become clear. First, the universe definitely expands and has been expanding as predicted by the Big Bang theory. Okay, but then what did the scientists question? Why did we have studies with unusual titles, or the astronomers saying that they have trouble sleeping because of these new discoveries? Well, here it actually has something to do with the evolution of early galaxies. The initial evolution of some of these early galaxies did not progress as the scientists originally predicted. It looks like the galaxies were able to form much earlier, developing into larger structures and into more cohesive structures with more success than some of the early simulations predicted. And that's of course what the scientists are currently questioning. They're basically questioning some of these simulations we have and some of the early predictions about how early galaxies formed. Something here doesn't match. Everything else though matches exactly. And so the Big Bang theory is not questioned by anyone that does these studies. However, what is being questioned is what exactly happened to these early galaxies to form them so quickly and to make them the way they are. It's actually more of a question of some of the early particles and potentially some of the ideas in regards to dark matter or something else mysterious going on here that very likely affected these early galaxies as the universe was expanding in the first 200 million years. But I guess more importantly, all of these images from the James Webb, all of these new galaxies discovered, everything here actually confirms everything we've always believed about the universe. There is absolutely nothing here to suggest that any of the major theories are incorrect. As a matter of fact, it's quite the opposite. Everything here confirms modern cosmology. For example, the strange lensing effect here confirms that there is the mysterious dark matter in this particular cluster. These redshifted galaxies confirm that the universe is expanding really fast the farther back you look. And the fact that these galaxies are much smaller and much less developed confirms that the evolution of the universe most likely progressed as the scientists initially predicted, with certain inconsistencies. And so the conclusion here is that the Big Bang right now is the best theory we have that explains the cosmology and the beginning of the universe as we know it. Hello wonderful person, this is Anton, and today we're going to be looking at and discussing a few more pictures from the James Webb Telescope that recently became publicly available for everyone to peruse. And although by now we've seen a lot of incredible pictures from this telescope, I think today you're going to see some of the best ones, at least one of them. And interestingly enough, most of these pictures have actually been produced not by professional astronomers, but by people like you and me, either amateur astronomers or citizen scientists simply doing this as their hobby or for fun. And there's one particular person that's been doing an incredible job at producing some of the most mind-blowing pictures. This person right here, Judy Schmidt, who started producing these images approximately 10 years ago, mostly for fun, and has now become not just an expert, but one of the best experts in being able to take raw data and create something visually stunning out of it. As a matter of fact, in some of the previous videos, a lot of these images were produced by her. And you can actually check out her Flickr account to see some of these images. Flickr? Who still uses Flickr? I used to use it a long time ago. But anyway, moving on. Let's talk about what she produced, what these images mean, and how all of this was made. And let's start with the best image we've seen so far. The image of Jupiter. Jupiter with so much detail that it actually really surprised a lot of the scientists. We see so many more features here that have ever been seen before. Now by itself, I could probably spend an hour just talking about this picture alone. There's just so much happening here. And let me just show you some of the things that Judy was able to recreate. So first of all, we definitely see the rings of Jupiter. They're not as big as the ones on Saturn, but they're surprisingly easily visible here, along with the moon Adrastea that's actually part of the rings. And the slightly larger moon, Amalthea, right next to it. Now you might remember when the James Webb Telescope released its first image, it had these huge diffraction spikes that are actually formed because of the hexagonal shape of the telescope. And extremely bright objects will usually produce extremely long spikes. As you can see in this case, we also see several diffraction spikes from the relatively bright southern aurora, which most likely resembles something like this. But remember, this is in infrared light. So in this case, it seems to produce very bright infrared emissions. Around the same spot, there's also Io's footprint. And this is sort of produced by the interaction of moon Io and the material that's escaping from the moon and the very powerful magnetosphere of Jupiter. We've discussed some of these concepts previously in the video that should be right there or maybe in the description. With the image also revealing a lot of different swirling around the northern and southern poles. It becomes easier visible in this other image produced by Judy, where the swirls are represented in yellow and green. And in this case, these hazes are just different types of gases with very specific temperature visible to the James Webb Telescope. And the bluish colors you see on Jupiter is essentially the light reflected from the deeper parts of the clouds. Although interestingly, the iconic Great Red Spot appears entirely white simply because it seems to reflect a lot of sunlight in various frequencies. And because it's much higher in altitude than other clouds, it forms very different colors as well, with various storms also represented with bright colors. But interestingly enough, even in this image, it seems that there are at least several galaxies, really far away galaxies, that are sort of visible in the background. And it looks like this is going to be the case for every image that James Webb Telescope takes. These galaxies are going to be photobombing everything every time. But anyway, a pretty amazing picture and an incredible recreation of the data from the James Webb. Although as a side note, all of this is publicly available, so in theory anyone could create this. Now I'm probably going to be making a video about how to do all of this and how to actually create these yourselves, but it's a much more technical video and obviously will not appeal to everyone. Nevertheless, in a nutshell, what Judy does here is use one of the freely available data products from NASA, such as the ones you find right here, known as the MAST, Mikulski Archive for Space Telescopes. And all of this data is publicly available and it's constantly updated, meaning that anyone can actually download this, but it doesn't come as a JPEG file. It comes in a format known as FITS, which by itself will usually look like a monochrome or black and white image with just raw data in it. And so it actually takes quite a while for a lot of astronomers, and in this case Judy, to take individual frequencies and assign colors to them, while also processing these images in other ways, in order to make them look so brilliant and so beautiful. The raw data by itself does not look anything like this. And as a matter of fact, in the past when I tried to do this myself, it takes hours and hours of work just to get something that kinda looks like some of the pictures we see. But it does take a lot of practice and a lot of understanding of the limitations of individual instruments in order to create something remarkable and something amazing. But as I said, in theory, it's totally possible to do this for anyone. Just take some time and a little bit of practice. In other words, if you do have a lot of time on your hands, get on it. Okay, moving on to the second image. So this was also based on some of the raw data released by the telescope and not detected by anyone before, but also not really processed in any major way either. Nevertheless, here's what the scientists discovered. This is at a distance of roughly around 2000 light years away from us. And it's an object that seems to be only visible in certain frequencies of infrared light, suggesting that it has a temperature of about 600 Kelvin, just a little bit cooler than Venus, but much hotter than Earth. And what you're looking at right here seems to be some kind of a brown dwarf, specifically a T-type. An extremely rare type of an object that until now was always extremely difficult to find because they don't really produce a lot of light. And unlike some of the other brown dwarfs such as L dwarfs, which do produce a lot more heat and have more frequencies coming out of them, T-dwarfs generally seem to be kind of dim, but looks like bright enough to be detected by the James Webb. And specifically they seem to produce just the right colors and just the right amount of heat in order to be visible 2000 light years away. Which also implies that some of the data from this particular study and these recent images are going to serve as a kind of a groundwork to discover possibly thousands, if not millions, of these objects in places where they've never been seen before. Up until now, only 400 of these objects have been discovered, with this particular object very likely resembling something like this. Something that's about 31 masses of Jupiter, about 5 billion years old, so just a little bit older than Jupiter, with the constant temperature of 600 Kelvin. But for now, that's kind of all we know about this object and about this image. Okay, next image. Once again from Judy Schmidt. This time a galaxy known as NGC 1365. A very intriguing galaxy that seems to have not one, but two bar-like formations right in the center. There's a longer bar and a shorter bar inside of it. All of this approximately 56 million light years away from us. Just to give you an optical comparison, here's what this galaxy looks like using some of the other telescopes, such as the ones located in Chile. But naturally, the infrared light reveals a lot of new detail that was previously invisible. As a matter of fact, because there's so much gas here that seems to hide the internal structure of the galaxy, this particular galaxy was chosen as one of the first targets for the James Webb. And right away, that second bar becomes much more visible in infrared images. In this case, the scientists believe that this particular bar very likely causes a lot of the gas to be drawn into the core of the galaxy in order to both form new stars, but also to feed the supermassive black hole in the middle. The black hole that's about 2 million solar masses, or about half the size of the one in the middle of our own galaxy. And because of this, the center here, as you can see, is kind of bright. It's bright because this is an active galactic nucleus. The black hole here is actively feeding and producing quite a lot of heat and a lot of energy, but not as actively as some of the more massive ones. Although I guess one intriguing question is, why is it that it has this unusual shape here? Well, it seems that the inner bar rotates a little bit faster than the larger, longer bar, and that creates a diagonal shape that you see in this image. But this is naturally just some of the first images and some of the first discoveries. The actual studies about this galaxy are not complete yet, so we don't really know what the scientists are going to find here, but it's definitely going to be interesting to find out. Anyway, let's go to the next image. Actually, this one is more of a mosaic of 690 individual frames and covers an area that's about 8 times larger than the first image revealed by the James Webb. Here it's kind of difficult to see the detail, But it's full of different galaxies with many never seen before, with the actual image, the one with high resolution, being way too big for me to even display on this computer. It just cannot open it without crashing. With the scientists behind this image already discovering some of the more ancient galaxies as well that we've discussed in one of the previous videos. In this case, the one with the redshift of 14. And then we have this image right here that potentially shows the formation of some of the earliest globular clusters in existence of the universe. The objects that even today are kind of mysterious in terms of their origins, but objects that are generally used for a lot of different analysis and a lot of studies in modern astronomy. There are actually quite a lot of them in the Milky Way, roughly around 150, and today it's believed that all of these are remnants of ancient galaxies and specifically their cores. And as the Milky Way galaxy interacted with them, only this was left behind. And normally these clusters are only about 100 to maybe 200 light years across, but will contain thousands and thousands of different stars, sometimes even several million stars in a relatively small volume of space. More importantly though, all of these are extremely old. They very often possess some of the oldest stars in the universe, or at least in our own galaxy. But at the moment it's not really entirely clear how they were actually formed themselves. We understand that they probably had something to do with ancient galaxies, but what exactly formed these objects? Well, today it's believed that many of them are at least 12 to sometimes 13 billion years old, suggesting that they were created around the redshift of 5. Or essentially, if we were to look back in the universe at the redshift of 5, we should be seeing the formation of these objects. And so one of the possible formation theories here is really in regards to the initial galaxy. Maybe these clusters are formed with the initial galaxy and need a lot of different gas and a lot of different stars in order to assume their shape. Although eventually, as the galaxy evolves, it might interact with other galaxies, leaving behind nothing but the cluster itself. Or maybe the clusters form naturally from something else and using some kind of other mechanism, and would actually require high density of gas and stars to form, which means that they would generally not be forming anymore and would only form at certain times in the universe. And so to try to answer some of these questions, the scientists once again used one of the images that we've talked about before, SMACS J0723, with a very powerful gravitational lens that allows the scientists to see really far away, with a specific focus being very small point sources seen around the gravitational lenses. In this case, the scientists refer to them as sparkles, with one galaxy named Sparkler, because of its high magnification of about 100, revealing quite an interesting sight. You're essentially looking at a very distant galaxy that existed about 9 billion years ago. And here they find at least 12 of these sparkles around the Sparkler. Or in other words, potentially 12 globular clusters around this young galaxy. And at least 5 of them seem to be evolved globular clusters that already existed at this period of time. But also, since these are globular clusters, it looks like the star formation has already stopped there, which potentially implies that these objects form in some natural way without the need for a galaxy. And more specifically, they might have formed in the first 500 million years of the existence of the universe, because back then the universe was much denser, there was a lot more gas, way more stars, and a lot more of these objects could have formed using some natural phenomenon that we still don't really understand. And even though we still don't really exactly know how globular clusters formed, images like this one are taking us a step closer in order to answer these mysteries once and for all. Lastly, we have this image. Okay, actually this is another interpretation of the image I just showed you, but in this case it shows us what the scientists think is some kind of a galactic protocluster, with the red and green circles showing us the galaxies that are very likely coming slowly together, representing a progenitor to what you see right here. An actual galactic cluster with a lot of mass inside of it, which then is sometimes used as a gravitational lens. But in this case, they still have not combined into a larger cluster and are still slowly approaching each other, with one of the main discoveries coming from the study being in regards to the amount of invisible mysterious dark matter present in these galaxies. It actually seems to match the amount we typically expect from a much larger galactic cluster, which means that by the time these galaxies combine into a larger formation, they're basically going to resemble something like this: a lot of dark matter, several galaxies in the middle, huge amounts of mass. But in this case, this is the light that traveled the universe for 13 billion years, meaning that this is still early universe and the galactic clusters still have not formed. And so the data from this particular study might actually help the scientists figure out how these huge clusters ended up forming in the last few billions of years, and why so many of them eventually acquired so much mass that they now create these beautiful lensing effects. One of the more exciting prospects of James Webb Telescope is its ability to detect atmospheres of a lot of different types of exoplanets out there. And not just detect atmospheres, but definitively tell us what's inside those atmospheres, even detecting some of the more rare gases that we've never seen before. And although the actual process of finding this hasn't changed much, in this case the scientists essentially look at the starlight as it passes in front of the planet, and the part right around here tends to absorb some of the starlight in a very specific way, producing what's known as the absorption spectrum. What has changed is the incredible power of the James Webb to see very specific absorption spectra and provide incredible detail that was previously unavailable. Which is precisely what happened now with the recent paper that you can find in the description, describing one of the most incredible discoveries when it comes to atmospheres of various planets, at least for the space sciences. Hello wonderful person, this is Anton, and so today we're going to discuss this new discovery from the James Webb, talk a little bit more about its importance, and also discuss what all of this means for the future of various exoplanetary studies and what we can expect before the end of the year. But I guess first, what star is it and what planet is it? So this star is known as WASP-39, and interestingly enough, it's a G-type star extremely similar to our own Sun. A little bit smaller and less massive, but very similar in a lot of other ways. And in this case, this star and this planet are one of those rare objects that actually have proper names given to them by astronomers back in 2015, with the planet itself being discovered much earlier back in 2011. So the star is known as Melmoch, and the planet is known as Boca Prince, named after a national park in Aruba, with the distance to the star system being approximately 700 light years away from us. But even though the star is kind of similar to our Sun, the star system is most likely extremely different. So for example, this planet, that's considered to be a sub-Jupiter, is extremely close to the star itself. So close, as a matter of fact, that as you can see, it's even losing a lot of the mass because of the evaporation. This ends up creating this beautiful tail that you see right here. At least that's what we think it kind of looks like. And in terms of mass, it's about 1/3 of Jupiter, or very similar to planet Saturn, but it's also much bigger than Jupiter, about 1.3 times as big, meaning that it's a kind of a Puffy planet. A planet that's sort of inflated so much that it's much bigger than a lot of these similar planets. Because of this, its density is also extremely low. It's roughly around 0.18 grams per centimeter cube, or like 30 to 40 times lower than planet Earth. Saturn, which is one of the least dense objects in the solar system, is at least 5 times as dense. And all of this is mostly because of its temperature. It's very likely approximately 900 degrees Celsius here. And all of this is because it's so close to the parent star. A single orbit here is about 4 days. And in the past, the scientists were super interested in this planet because of its unusual properties. Obviously, because of the puffiness, it's a lot easier to see the atmosphere here, but at the same time, previous studies have already started to discover unusual atmospheric composition that was just difficult to explain. For example, some of the first observations here have already detected quite a huge amount of water vapor, as well as sodium and potassium. This was seen with Spitzer and Hubble telescopes, with several studies suggesting that there's some kind of a disequilibrium or some kind of an unusual mixing going on inside the atmosphere of the planet, which is not usually seen around these types of planets. In other words, the composition was potentially different from your typical gas giant. Most of the planet was still helium and hydrogen, but the other stuff was different from other planets. Although a bit of a side note, when it comes to detecting atmospheres on various planets, these particular detections are still in their infancy. For example, it's actually only in 2001 that for the first time ever, the scientists were able to detect signs of sodium in the atmosphere of another planet, a distant exoplanet nicknamed Osiris. And some of the first potential signs of water and carbon dioxide, and even methane, came in 2008 from this planet right here. But all of these were just signs, suggestions, not actual detections, like what we have right now in this particular case. In other words, up until recently, it was actually kind of difficult for the scientists to determine actual gases in various exoplanetary atmospheres. However, this time, the detection was extremely obvious. And it was really because of the ability of James Webb Telescope to observe certain infrared frequencies so well. This time, the James Webb Telescope was able to use its infrared sensors to observe the right range of frequencies in order to definitively detect a lot of different components of the atmosphere and more specifically, definitively confirmed that this planet has carbon dioxide. And as of today, this is the most definitive signs of carbon dioxide present in the atmosphere of another planet. Here, the confirmation was 26 sigma. In terms of this being statistical anomaly or potentially some kind of a signal noise, the odds here are 10 to the power of 149 against 1. So yeah, quite a low chance. As a matter of fact, in this case, such a high signal level has never been seen before. With all this being between 4.1 and 4.6 microns in wavelength, which represents carbon dioxide. And normally the scientists would require a lot of modeling, a lot of processing and reprocessing in order to see all of this. This time, they pretty much saw it almost right away after just 8 hours of observation, with the peak here being very obvious, and with the passage that took just a few hours, being able to show the scientists the absorption spectrum of the atmosphere. And because different gases are going to be absorbing different combinations of colors, it becomes very easy for the scientists using this telescope to definitively determine what's inside the atmosphere by just looking at it for a few hours. But somewhat unexpectedly, by looking at their data, they also found another signal they cannot currently explain. Something else appeared right around here, another signal that the scientists currently do not have data for. It's not reproduced in any of the current models, and it's not entirely clear what sort of a component or what kind of a compound can produce these particular signatures. But once again, this planet already is known to have unusual composition and unusual mixture on the inside. And so it's just another mystery for the scientists to play around with and to try to figure out in the next few years. For all we know, this unusual planet might have some unusual gases there that we've never really seen anywhere else before. At the moment, it's just some kind of a mystery molecule with an absorption spectrum we've never seen. But more importantly for various terrestrial exoplanets, because of the ability of James Webb to detect this so well, the scientists are now going to be applying this technique to a lot of other exciting objects, with most likely the first on the list being one of the terrestrial planets in the now iconic TRAPPIST-1 system that has at least 7 terrestrial planets orbiting around the central star. By discovering CO2 around these planets, or maybe some other signs of chemical reactions or gases that are often produced by life here on Earth, for all we know, we might actually be discovering extraterrestrial life in the next few months, next few years, or relatively soon. In other words, the results from this study are super exciting. It means that James Webb is so good at seeing this and is going to be able to see a lot of exoplanetary atmospheres. But when it comes to this particular planet, there are still a lot of unanswered questions, specifically in regards to its origin and why it's, well, first of all, Puffy, but second of all, why it has such an unusual composition for a gas giant, how exactly it was created, where it was created, and what is that mysterious molecule discovered in this study. So I'm sure we'll be talking more about this in some of the future videos as well. Hello wonderful person, this is Anton, and once again we're going to be discussing some of the more recent updates and some of the more interesting updates from the James Webb Space Telescope. With the main focus once again being the images from the telescope, with a brief explanation for each of the images released as well, and this time there were actually quite a lot of different, really impressive images, with many, like this one right here, once again revealing so much new information that has previously been invisible to us. And so let's discuss some of these new images and some of the new discoveries in more detail, and let's actually start right here. If you watched one of the previous videos from a few weeks ago, you might already know exactly what we're looking at right here. This is one of the most recently released images from the James Webb of the iconic Tarantula Nebula, which represents an extremely active star-forming region in the nearby galaxy known as Large Magellanic Cloud. We've discussed this galaxy in one of the previous videos when I actually talked about some of the recent discoveries from the iconic star known as R136A1, the most massive star known to us, and that particular star is located in this region, and is actually even visible in this image, although it's relatively small because there are so many other stars in here. But this time the image released by the James Webb simply uncovered a lot of detail that was previously invisible by Hubble and by a lot of other telescopes. And so we don't actually know what's going to be discovered here just yet, because all of this is completely brand new information. But because all of this is obviously publicly available, the researchers are now going to be studying this, trying to discover something new in the process. But what makes these future studies super exciting, and actually what makes this image really exciting as well, is the fact that in terms of chemical composition, and also in the way that the stars form here, this particular region is very similar to a lot of star-forming regions observed in the universe approximately 9 to 10 billion years ago. the period we often refer to as the cosmic noon. And so because of these similarities, this region has always been super intriguing for the scientists, helping them understand the entire evolution process of the universe for the past 12 billion years. And so in this case, the Tarantula Nebula is literally like looking back in time, but basically on our doorsteps. Which is why I'm sure there are going to be so many intriguing studies about this image in the next few months. The next on the list is this image from the recent study you can find in the description below that once again discovers a really intriguing star, an extremely magnified star located in a galaxy that existed 11.2 billion years ago. And in this case, a star magnified by about 10,000 times. Although in this particular case, it doesn't really break any records because it's not really the most distant star, neither it is the oldest, but it's still an extremely intriguing discovery, especially because there's only like a handful of these objects that have ever been discovered, with all of them discovered because of the very powerful gravitational lensing effects formed by some kind of an extremely massive cluster in front of the object. And intriguingly enough, this particular concept was still theoretical back in the 90s. And one of the first examples of an extremely magnified star was only discovered in 2018. This is a star we discussed, known as Icarus, located at the redshift of 1.5. And much more recently, only a few months ago, we discussed the most distant star discovered, known as Arendelle, located at the redshift of 6.2. You can find the video somewhere in the description. But in this new study, what makes this detection particularly interesting is that it actually kind of seems to be a double magnification. It's magnified by the cluster, but it's also magnified by some kind of a solar mass microlens, which may suggest it has some kind of a partner. And because of the extremely high magnification here, the scientists already have a lot of details about this star. It seems to be some kind of a blue supergiant with a surface temperature of anywhere between 7 to 12,000 Kelvin, and it also naturally seems to be very bright, and very likely resembling what you see right here. But because the lifespan for such a star is usually only a few million years, it means that this star only existed for a very short period of time before disappearing and most likely becoming a neutron star or maybe a black hole. So once again, this is actually a chance discovery. And speaking of gravitational lensing, very recently one of the Reddit users, whose link you can find in the description, was able to process one of the images from the James Webb, capturing an almost perfect Einstein ring, approximately 12 billion light years away from us, showing us some kind of a galaxy that's aligned in just a perfect way to create this beautiful image. Although what's interesting here is that it actually looks differently depending on the instrument used. This is what it looks like in the near infrared, and this is what it looks like in the mid-infrared, which by itself is already just enough data for some of the scientists to potentially start analyzing exactly what's happening here, and maybe even recreate the original image. But because of the extreme distance to this object, it's still going to be kind of difficult to recreate this, but we know that this is a galaxy. Next on the list is an exoplanet. The first ever image of an exoplanet directly captured by the James Webb using its infrared instruments. This is a planet known as HIP 65426b, originally discovered back in 2017 and roughly around 385 light years away from us, and a planet that was already seen by other instruments as well. So this isn't really a discovery as much as a test of the instruments and the ability for the James Webb to see these planets as well. And in this case, what this proves is that we're now able to see planets in very specific infrared frequencies that were previously invisible to us. And so this super Jupiter that's about 6 to 8 times more massive than Jupiter itself, and also orbits an A-type star, was not just easily visible, but also visible in a lot more detail that the other telescopes are just not able to produce, which allows the scientists to see these planets in a much wider view that was previously unavailable to them because of the limitations in different wavelengths. And because of this, the scientists can now actually obtain a lot of properties of these planets, including things like mass, temperature, radius, and even in further composition simply based on the wavelengths observed. And because here they use 7 different filters, and each of them allows certain wavelengths to pass, it allows the scientists to see so much more detail than ever before. And more importantly, they can now apply this to much smaller exoplanets as well. And though unfortunately we may not be able to see some of the terrestrial planets just yet, seeing the smaller gas giants and planets like Neptune and Uranus now becomes a possibility as well. But what exactly we're going to be finding about this planet in the future, or what other planets we're going to be discovering, is still not really known to us. And then we have the gorgeous images from the iconic galaxy known as M74, also known as Phantom Galaxy. And in this case, this was actually taken by 2 separate telescopes, the Hubble and the James Webb. And the main reason the scientists used two telescopes was actually to try to see what the difference is going to be. Specifically, they actually wanted to focus on different frequencies. And so the Hubble image that's on the left is definitely very different from the Webb image that's in infrared on the right. And when combined in the middle, it really transforms how we've always imagined this particular galaxy, which looks entirely different from how we saw it originally. This is back from 2013, nearly 9 years ago. And here is the same image taken by the infrared Spitzer telescope. And this galaxy has already been studied for many years. It's about 32 million light years away from us. It's also an iconic type of a spiral galaxy, also known as Grand Design Spiral, because of its prominent and well-defined spiral arms. But what's invisible in these optical images, and what's hidden by the gas, are all of the superactive regions where the stars actively form. So this is the image from the James Webb. And each of these red spots are these huge clouds of hydrogen gas, known as H2 regions, where there's a lot of star formation, very similar to previously mentioned Tarantula Nebula, except in this case, we actually have so many of them all over the place, with these regions being one of the main reasons for these images. Mostly because we believe that the Milky Way galaxy very likely looks something like this as well, just from a different angle. And in this case, the Hubble's view of this galaxy shows us the older and the much more red stars toward the center of the galaxy, and the younger bluer stars in the spiral arms, while also showing us some of the active stellar formation in the red bubbles. However, the James Webb image is extremely different. It highlights the masses of gas inside the galactic arms, but also shows us extremely dense clusters formed by different massive stars, especially the one at its core. You can sort of see this if you zoom into this image. And this is something we've never actually seen before until these recent images. The Hubble image unfortunately is not able to distinguish any of this. And then the combined image presents this galaxy as the mixture of two, and that's very likely what our own galaxy looks like as well. But this is just the first of 19 upcoming images of different nearby star-forming galaxies. Galaxies that are very likely similar to our own, but also tend to produce a lot of stars at the same time. So we're going to be seeing 18 more in the next few months, with the main purpose naturally being understanding the star formation and star evolution in various galaxies. And so within a year from now, we're most likely going to have a lot of intriguing pictures and a lot of intriguing answers. But not yet. Well, let's go to the next image. Okay, not really an image, as much as the observation of the atmosphere of a distant brown dwarf. Specifically, the one that very likely looks something like this. This is a simulation created by NASA a few years ago. And this time, the scientists were able to directly observe some of the atmosphere and specifically some of the clouds in this particular brown dwarf. The silicate clouds in the atmosphere of the brown dwarf located 72 light years away from us, known as VHS 1256-1257b, originally discovered approximately 7 years ago, with the brown dwarf being about 19 times the mass of Jupiter, but also being relatively young, while also being relatively reddish in color, very likely because of its atmosphere. And previously it's been assumed that it's actually because of the specific types of silicate clouds located in the upper atmosphere. And so by looking at this brown dwarf in the infrared, the team behind the study in the description discovered water, methane, carbon monoxide, carbon dioxide, sodium, potassium, and silicate particles, silicate clouds, very likely formed by various types of minerals such as phosphorite, andesite, and quartz. All of this as extremely small grain particles, much smaller than sand, forming these very large clouds, which actually confirms that in certain young brown dwarfs, these very thick clouds can influence observed brightness and can actually make them appear much different from other brown dwarfs. And so a pretty interesting discovery for the scientists studying these objects. Hello wonderful person, this is Anton, and once again, let's discuss the James Webb Telescope. Let's discuss some of the new images released by the telescope in the last week or so, and also talk about one major issue it has recently experienced that the scientists are currently having trouble resolving, but it's not really going to jeopardize the mission in any way, it's just making some things a little bit more difficult. And let's actually maybe start with that. So what's happening with the James Webb, and what is that new glitch? Well, first of all, as you probably already know, this is not the first time there is a glitch on the telescope. We've discussed the first issue a few months ago, when the scientists discovered signs of a relatively large meteoroid impact that affected one of the mirrors. but as you know by now, because of the design of the telescope, it actually has not affected much in terms of the general operations. And as a matter of fact, these collisions are expected. You can find a little bit more detail about this in the video in the description. But the new glitch is something that was unexpected and currently does not have a good reason or a good solution. And in this case, the glitch is inside the instrument known as MIRI, one of the main instruments responsible for mid-infrared imagery. And as you can see from this animation, whatever is happening inside the telescope is ridiculously complicated. It actually has one of the most sophisticated three-dimensional structures ever produced in any telescope. But very recently, during one of the observations, the telescope reported unusual data coming from MIRI itself. There was an unusual increase in friction in one of the mechanisms when operating in the medium-resolution spectroscopy mode. And this really complex instrument has 4 different modes of operation: the imaging mode, low-resolution spectroscopy, medium-resolution spectroscopy, and coronography, with each of these modes passing their initial tests back in June of 2022. But a few months later, and specifically at the end of August, during the operation of medium-resolution spectroscopy, the science team detected a small problem with one of the wheels. Specifically, one of the wheels responsible for the motion inside MIRI, and for some reason there is an increased amount of friction inside this mechanism, which might with time cause a bit of an issue. But there was no issue yet and nothing is broken. But because the scientists want to be super careful with the telescope, and they obviously don't want any of the parts to wear out too quickly, they decided to pause all of the future observations of this particular function inside MIRI, relying on the 3 remaining modes, which seem to be working properly. But until the engineering team can figure out exactly what's happening here, they're not going to be able to find a solution. Chances are though, within the next few months, they will. Because as we know, the engineers at NASA are some of the most brilliant engineers on the planet. I didn't really get to talk about this yet on the channel, but just a few weeks ago, the engineers have already found a solution to one of the glitches on the Voyager probe that I've talked about a few months ago. And so if they manage to fix this almost 50-year-old probe that's one of the most distant objects in the solar system, they're definitely going to be able to find a solution to this problem as well. And once they do, I'll make sure to follow this up with another video. So subscribe if you want to learn more. Anyway, let's discuss some of the new images released by the team, with some being kind of mind-blowing. I actually wanted to start with the one that was just released. The image of the most distant planet in the solar system, Neptune. And an unusual star you can see right here. Guess what it is? So this is the first time ever we've seen Neptune in this unusual light. And as it becomes pretty obvious, this is the first time ever we've seen Neptune's rings with so much incredible detail, and some of these rings have never been seen before, making the rings of Neptune appear almost as big as the one around Saturn. Although they're definitely not, and they do have very different formation history, because as we've recently learned from Saturn, and as we're going to be discussing in another video, which might have been already released on the channel, in case of Neptune, the rings were most likely formed by some kind of an ancient asteroid coming a little bit too close to the planet, and very likely coming from the distant parts of the solar system. Although to be honest, at the moment nobody really knows how exactly they formed. Then, by zooming in even closer on the planet, we can actually start seeing some of the darker spots, which are produced by the methane gas, which absorbs some of the infrared light that would be otherwise visible to James Webb. As a matter of fact, compared to, for example, Saturn, which was very bright in these particular frequencies, Neptune appears relatively dark, with a lot of frequencies being absorbed, except for occasional high-altitude clouds, which appear extremely bright because they're above the methane. But interestingly, these particular clouds are very likely made out of methane ice. So it's the methane gas that's absorbing, and methane ice is reflecting. With this barely visible thin line on the equator that you can kind of see right here, very likely representing the global circulation of the atmosphere on the planet, which powers pretty much all of the storms and all of the other weather effects on the surface of Neptune. With another intriguing feature being the previously known vortex at the southern pole of Neptune, which sort of looked like this in the Hubble images. In this case, also revealing a continuous band of clouds surrounding the vortex. But at the same time, the image also captures 7 of the 14 known moons, with that extremely bright star I previously mentioned being Triton, the biggest moon of Neptune that orbits in the opposite direction of everything else. And so most scientists today believe that Triton was very likely captured from somewhere on the outskirts of the solar system, specifically the Kuiper's belt, and is very likely extremely similar to objects like Pluto. But what makes this image so unusual is how bright Triton is in these frequencies. It really looks like a star. And that's because most of the surface is covered in nitrogen ice. once again very similar to what we find on Pluto. And in this case, nitrogen ice reflects certain frequencies of light, specifically the infrared frequencies, making it appear extremely shiny from these distances. And so while Neptune itself is relatively dark, Triton is extremely bright, making this an extremely intriguing image that's going to be providing data for months and even years to come. And then we have another image from the solar system, this time a little bit closer to home. For the first time ever, James Webb released the images of Mars. But because Mars is so close to us and because it's actually quite bright, and also because the James Webb Telescope is relatively sensitive, the scientists had to use several observational techniques in order to avoid what's known as detector saturation, or essentially the excess of light that can generally prevent the telescope from being able to see anything. And so here the scientists used very short exposures, allowing only some light to enter the telescope, which allowed the scientists to see some of the dust layers, several different craters, and various dark spots, and an unusual dark feature you see right there known as Hellas Basin. And the reason why it's so dark is of course kind of interesting. So first of all, one of the main reasons why there's a very bright spot on the left side of Mars is because that's basically where the sun is warming up the regions. It's where the sun is almost directly overhead, with some of the cooler areas being along the poles of the planet. And because in this case the observations are in 4.3 microns of infrared light, it actually is directly related to the temperature surface of this planet. And so the brightest regions basically show us the hottest regions. But because we also know that CO2, carbon dioxide, tends to absorb some of these frequencies, which is of course why it's also known as the greenhouse gas, and because we also know that most of the atmosphere on Mars is carbon dioxide, some regions, such as various grooves or various craters that are much deeper than the rest of the surface, will generally contain much higher atmosphere because the atmospheric pressure here is going to be much higher. And in this case, the Hellas Basin is one of these regions. There's more CO2, more atmospheric pressure, and thus it appears slightly darker, because CO2 is absorbing some of this light and does not allow it to reflect, but keeps it inside the planet, warming up this region. In other words, this is a visual representation of the effects of greenhouse gases. But more importantly for scientists, the instrument was also able to measure the atmospheric composition of Mars, and unlike various rovers on Mars, which only measure the atmospheric composition very close to where they're located, in this case, the instrument was able to see the entire atmospheric column, allowing it to capture pretty much the entire atmosphere and all of the gas emissions coming from here. Which is really important because the scientists really want to solve one of the major mysteries on Mars, the unexplained detection of methane, for example, which has been previously discovered by one of the rovers, but has never really been officially rediscovered or proven to be formed somewhere on Mars. And so by doing this more thoroughly, the scientists might actually find the source of methane and thus figure out where all of this is coming from. Methane is of course really important because it's one of the possible biomarkers, so by finding its source, the scientists might be able to answer the question of maybe life on Mars, or potentially discover a very unusual inorganic source of all of these molecules, while at the same time helping the scientists discover some other unusual elements, such as for example hydrogen chloride, that has previously also been discovered on Mars, and thus allow them to understand the planet a little bit better. But for now that's all we know about Mars. And now for the last image, we're going to go a little bit farther away. The beautiful Orion Nebula, one of the most iconic features in our neighborhood of the Milky Way galaxy. And in this case, we now get to see the inner region of the Orion Nebula like once again we've never seen before, which, if you were to look in the night skies, is part of the much bigger structure referred to as the Orion Molecular Cloud, with the nebula itself visible right there. And so here's kind of what we're looking at in this image. For example, right here, one of the young stars becomes quite apparent, with another star, Orionis A, being even brighter and more easily visible than ever before. For the first time ever, we also see some of the young stars with extremely young protoplanetary disks and actual cocoons formed around them, as well as certain other features such as these filaments that you see, very likely formed by various magnetic interactions. And the main purpose for this image is essentially trying to understand how early stars form and what happens in these star birthing regions, which is extremely similar to the one where the solar system was created as well. For example, we know that various ultraviolet emissions from extremely young stars generally play a very important role in changing the gas and the dust clouds in the regions where these stars form. And in this case, this very bright and very powerful triple star definitely seems to have quite a lot of effect on the nearby gas. Something that was actually previously invisible to us, because as you can see right here, the image from the Hubble telescope was unfortunately unable to uncover all of this since these regions also possess quite a lot of dust. And so only infrared observations were able to ignore the gas and were able to reveal the objects and the features we've never seen before. While at the same time, all of this extremely powerful light also very likely chemically changes the cloud as well. And so trying to understand how all of this works, and also how these other features, such as these filaments, form as well, is of course one of the main reasons this image was taken. And here's how all of this compares to the previous image from the Spitzer telescope, the telescope that operated for nearly 20 years, also observing everything in the infrared light. And so all of this of course implies that a lot of the activity inside these clouds is sort of interconnected. And though these dust clouds definitively produce these stars, the stars themselves then also create the necessary conditions where the clouds evolve and change dramatically based on the amount and the power of these stars, creating a kind of a feedback mechanism. And that's of course what the scientists want to understand a little bit better. With this particular object being particularly interesting because it really shows us how young stars form, and in this case providing extreme resolutions, allowing us to see things that are relatively similar in size to our own solar system. Hello wonderful person, this is Anton, and today we're going to be discussing some new updates, new discoveries, and new intriguing images from the James Webb Telescope and missions related to the telescope as well. And by the way, if you've missed some of the previous updates, all of the videos should be in the description. Now in this particular case, we're going to be focusing on some of the new observations of previous images, with new discoveries coming from the telescope in just the last few weeks, and also some really intriguing observations of the same images using other telescopes such as Chandra that allow the scientists to discover new detail and explain some of the things happening around various galaxies and various galactic clusters that were captured a few months ago. And let's actually start with one of these older images. The first image released by the James Webb team, the image of the cluster known as SMACS 0723 with an intriguing gravitational lens formed by the mass in the galactic cluster. And so very recently some of the scientists from Canada were actually looking at some of the data coming from the instrument developed by the Canadian scientists. The instrument that looks at everything in the near-infrared light identified several features that were initially missed by other scientists. Features that resembled extremely dense groups of millions of stars with extremely dense environments that made this unusual gravitational lens galaxy look kinda like this. They actually named this the Sparkler Galaxy, because these kind of resemble tiny sparkles. With a preliminary analysis suggesting that what they're actually seeing in this galaxy is very likely ancient globular clusters. Here's by the way how this image compares to the previous image from the Hubble, where you basically see nothing. And what's really impressive is that because of that particular gravitational lens, this galaxy is actually magnified at least 100 times, meaning that this is a super distant galaxy, with the light from these sparkles taking approximately 9 billion years to reach us. And more importantly, all of this seems to be around 3 billion years after the initial formation of the universe, during the period that the scientists refer to as the cosmic noon, when the universe had the highest star formation ever, and the period that the scientists today are actually extremely interested in studying. Mostly because these globular clusters probably contain quite a lot of clues about the earliest phases in the formation of the universe, formation of various galaxies, and the formation of various stars. And because 12 of these objects were discovered, the scientists believe that these are probably the oldest globular clusters known to us, very likely formed only millions of years after the formation of the universe. And in this case, this right here represents the earliest globular clusters ever seen. And because there is a bit of a mystery in terms of the formation of globular clusters, as a matter of fact nobody really knows today how exactly they were formed, this particular discovery might allow us to finally answer this question. But even if it doesn't, just the fact that the scientists were able to discover objects whose light is coming from the cosmic noon is already quite impressive. There are definitely going to be a lot of follow-ups on this discovery, and only time will tell exactly what the scientists find here afterwards. And even the globular clusters in our own galaxy, the Milky Way, and there's about 150 of them known today, have that mystery of their origin. Some of them are known to be ancient cores of dwarf galaxies, but some of them have very mysterious origins, and it's actually kind of difficult to explain why they even exist. We've discussed this in some of the previous videos you may find in the description. For the next discovery coming from the web, we're going to go to another galaxy, another beautiful spiral galaxy, known as IC 5332. In this case, this was the image taken by the Hubble telescope, but we now can also see it with the James Webb. And in this case, it looks almost entirely different. Now this is the second galaxy observed by both the Webb and the Hubble, and there are going to be at least 18 more in the future, with the first one discussed in the previous video, but in this case, because this galaxy is relatively close to us, about 29 million light years away, it's also a unique galaxy because it's almost entirely face-on toward planet Earth. And by observing this with mid-infrared frequencies with James Webb, we can now pierce through all of this dust and see the regions of star formation that were previously invisible. And this would never be possible to be seen from planet Earth or even from the environment around planet Earth, because mid-infrared is usually absorbed by most of the Earth's atmosphere. Now, in terms of the differences between the images, the Hubble image shows us these unusual dark regions that look like they're separating the spiral arms. But by looking at the same regions with the Webb telescope, we see a kind of a web-like structure that more or less follows the spiral arms. And this observational difference is really because of all of the dust present in a galaxy. The Hubble telescope sees things with the ultraviolet and the visible light, and all of this is usually scattered by the interstellar dust located in this galaxy. And you can see all of this with these darker regions where the UV light and the visible light cannot pass. But the infrared can go through them very easily, which makes this image extremely different. And it naturally also shows us different types of stars. And so in reality it almost looks like we're looking at two completely different objects, even though it's basically the same galaxy. Now, the actual studies about this galaxy did not come out yet, so this is just the first observation, but it already is quite impressive in what we can see now that could not be seen before. Although these particular regions where a lot of star formation is going on seem to be visible in both frequencies, and so it's most likely going to be the focus for future studies. And one of the main reasons this is done right now is because the scientists want to collect as many of these star-forming regions around our galaxy as possible, with the idea being a catalog of at least 100,000 star clusters with various molecular clouds in them that can actually help us understand how stars form, how they distribute gas around the galaxies, and how galaxies evolve afterwards. Which is why more of these images are going to be coming out really soon. Next on the list is another collaboration of Hubble and James Webb, and actually lots of other telescopes as well. This was the observation of the DART mission. More detail about this in the video somewhere in the description below, and specifically the observations of before and after the crash into Dimorphos, the moonlet of Didymus. This was actually observed by a lot of different telescopes, but James Webb and Hubble joined in, observing this during several periods, and kind of seeing something similar but something a little bit different. This right here is Hubble, and this right here is James Webb. And in this case, these observations are going to be in regards to exactly what the makeup of the asteroid was, because the light from these particles is going to allow the scientists to determine the exact composition. Hasn't been done yet, but the studies are coming out soon. It's also going to allow the scientists to reveal the size of these particles, the size of the expanding dust cloud, and help the scientists determine if it's mostly big chunks or mostly fine dust, thus allowing the scientists to understand if these types of impacts or these types of kinetic impacts can actually be effective at nudging the asteroid just enough to prevent it from a potential collision with planet Earth. Now, intriguingly enough, some other telescopes that are actually located on the planet, specifically in Chile, have already revealed this beautiful 10,000 kilometer long tail that was actually produced by the collision, something that nobody actually expected. Which already means that the collision might have caused a lot more damage than anyone anticipated, and the effects were more dramatic as well. And remember, the actual asteroid is only like 170 meters across. The tail is 10,000 kilometers. And so there's definitely something going on here that we currently cannot explain. The actual collision seemed to have caused way more effect than anyone ever expected. Here's that video once again of the moments right before the collision. These were actual pictures taken by the DART mission, with this image representing the most detailed picture taken right before the collision occurred. This was actually a combination of several different images. Now, it's still not entirely clear what we're going to be discovering about all of this in the coming months, but the actual mission so far has been extremely successful, and the actual data is already really impressive. And so that extra data from James Webb and Hubble is going to help the scientists understand exactly what happens when you collide something with an asteroid, but also help them figure out what this particular rock is very likely made out of as well. But interestingly enough, for the James Webb, this was a particularly challenging mission because of how fast the asteroid was moving across the night skies. It actually had to track the asteroid approximately 3 times faster than it was originally intended to track objects. In other words, the scientists used this opportunity to test the extreme capabilities of the telescope in tracking fast-moving objects, with some of these images already showing us a few surprises. For example, James Webb revealed extremely fast-moving streams moving away from the center where the impact took place, but the Hubble seems to show us rays that appear to be slightly curved. The scientists are not certain why all of this is seen this way yet, and so this is definitely going to be an interesting mystery to solve. And also in the Hubble images, the actual brightness of Didymos increased by at least 3 times, and it stayed as bright for at least 8 hours. At the moment, it's kind of difficult to explain why this happened, but it's quite possible that it's actually because of various ices released from the collision, which then reflected way more light than they did before. At least that's my guess. Not sure? We'll find out soon. Both telescopes are going to be observing the object at least several times in the coming weeks. And then we have some more observations from the Chandra telescope that essentially reanalyzed some of these previous images that we've seen before and discovered something new in the process. Here we're talking about the 4 initial images released by the James Webb. And so in case of the SMACS 0723 image, when the Chandra telescope looked at this in the X-rays, it actually saw something like this. What you're seeing is essentially trillions of solar masses of superheated gas. Gas that's only visible in X-rays, and gas that's tens of millions of degrees in temperature. But what's really intriguing about this gas is that it actually represents several times more mass in total than all of the visible galaxies in the entire cluster. And the scientists believe that there's even more invisible matter in this case, the dark matter, that's not visible in this image. Then when observing Stephan's quintet, it discovered some other unusual X-ray emissions that were not visible in previous images. In this case, it looks like this. This represents the result of the collision of some of these galaxies that forms a very powerful shock wave that heats all of this gas, with gas moving at millions of kilometers per hour. All of this is naturally a result of the interaction of these 5 galaxies. And this is kind of what's expected from these interactions, but it's just beautiful to see all of this connected to the original image. Then we have the Carina Nebula, the nebula that you see right here, and the purple stuff, that's the X-rays. And you can actually see that there are several features. There are these dots, and then there is this area right here. Now each of these dots are individual, very powerful and probably very young stars, 1 or 2 million years old. And most of the young stars will usually be extremely powerful in the X-rays, and with time as they age, they become a lot less powerful and eventually disappear. But this unusual diffuse gas you see right here very likely comes from some of the hottest and the most massive stars located in the nebula that essentially emitted all of this gas over time, forming this unusual diffuse X-ray field that seems to be present in this image. Definitely something really beautiful, and something that's, I guess, less expected. And lastly, we have the Cartwheel galaxy we've discussed before. This is probably formed by a collision with a different galaxy, something that happened about 100 million years ago. But in this case, the X-ray images reveal several regions of star formation that appears in the outer ring. All of this in this case very likely comes from individual exploded stars and various neutron stars, maybe some black holes, that very likely produce this as they essentially absorb the material from their companion stars. And so in this case, the X-rays reveal some of the more active regions with some of the most active star formation that naturally is also the brightest regions visible in the infrared as well. Together though, it looks absolutely stunning. So these are the new revelations from these 4 original images, allowing the scientists to see detail that was previously unknown to us and potentially helping us discover new things in the future. At the moment, we don't really know where all of this goes, but these are super exciting early discoveries, and it's really only been a few months before James Webb even became operational. So imagine what we're going to be talking about in a year from now. Hello wonderful person, this is Anton, and today we're going to be discussing some new updates coming from the wonderful James Webb Telescope, which includes some absolutely incredible images from some of the most iconic places in our galaxy. Such as of course the image that you see right here, that you might already recognize even though it looks a little bit different. These are the Pillars of Creation, the image that became extremely famous back in 1995 when Hubble took a picture of this particular region, revealing what you see right here. The nebulous region produced by the formation of various stars inside extremely dense clouds of gas and dust. But we now get to observe this in the infrared with the images from the James Webb Telescope that basically kind of sees through most of this, allowing us to now see things we've never been able to see before. With the dust and gas columns previously covering some of these locations now becoming more or less transparent, or at least semi-transparent in the near-infrared light. With this video slowly zooming us into this region approximately 6,000 to maybe 7,000 light years away from us, and basically showing us how all of this looks like if you were to see it in the infrared. And as you can kind of see as we're zooming in, this represents a typical star-forming cloud region, where a lot of activity from new stars starts forming various shapes and various patterns, redistributing matter and pushing clouds around because of all sorts of different activity from various types of stars. And one of the main reasons for this image is to get a better understanding of how stars form here and what exactly happens to these baby stars in the first few thousands of years of their existence. And we already see quite a lot of interesting detail in here. For example, newly formed stars, basically the youngest stars in the region, can be seen as extremely bright red orbs, particularly visible right here, with the beautiful red glow coming from these regions formed by energetic hydrogen molecules resulting from the activity of various jets and the shock that they produce when they strike the interstellar dust. And it's particularly visible in the middle pillar, which obviously suggests quite a lot of star activity and quite a lot of shock produced by these early stars, with many of these red dots, these red stars, very likely being less than 1 million years old and possibly only a few thousand years old. We also see quite a lot of really unusual wavy activity, which almost looks like this is made out of water or some kind of a liquid, and quite a lot of other unusual activity along the edges of some of these pillars. And these are most likely produced by the interaction of these early stars as they eject a lot of the material from their surface, basically as they develop and as they grow, but also possibly have something to do with the magnetic fields that are present here that then essentially create these patterns resembling wavy lines. But intriguingly, one thing missing from the image here are different types of galaxies. Galaxies that we always seem to see with the James Webb Telescope, but not in this case. It looks like this time a lot of the gas, mostly from the interstellar medium, blocked the view of the deeper universe, preventing us from seeing the galaxies that will usually appear in this case. And that's actually because this is located in the central region of the galaxy, where there is a huge amount of dust covering everything. It's very difficult to see through this gas. And so overall, definitely an extremely beautiful image and a contrast to what we used to have with Hubble telescope. And more importantly, this is definitely going to help scientists uncover what happens in these regions when the new stars form. And once the scientists discover something incredible here, I'll make sure to follow this up with the next video. Moving on to the next discovery. And this time something we've discussed in one of the earlier videos when I accidentally discovered this particular image somewhere on Reddit. Now this is a super exciting object, and actually one of the most rare objects, with the pattern that you see physically existing somewhere out there and not being some kind of an illusion. This is a binary known as WR140, and in a nutshell represents a very strange binary star with two extremely active stars. One, a Wolf-Rayet star, essentially a star that's releasing huge amounts of matter from its surface, with most of the hydrogen already gone from the surface, and its partner being a very active O-type star, also releasing huge amounts of matter, but maybe not as much. And because these two stars orbit around one another every 8 years, they actually end up releasing huge amounts of stuff at pretty much exactly the same time every time they come close to one another. And this ends up being visible as these beautiful concentric shapes, or these very unusual layers, with at least 20 different shells visible from a distance. Now back then we only had the image and no actual studies, but now the scientists have finally released 2 different studies analyzing this in a lot more detail. Both are obviously in the description below, revealing a few more things in the process. So I guess first of all there is now a chemical analysis of what's present inside these shells, showing us some of the elements that are being released by these stars. There's also a much more detailed analysis of different structures and different patterns that are formed here, with at least one potential discovery of something unusual that the scientists currently cannot explain. But more importantly, through the very detailed analysis of these extremely beautiful shells, and a comparison of a computer model that tried to recreate what the scientists think might have happened here, they've discovered that there is a bit of an extra acceleration inside of these shells. Or in other words, this unusual colliding wind binary, as it's also known, seems to have a little bit more force coming from inside, with the force itself very likely being created by the starlight coming from these 2 powerful stars. With the computer model here trying to recreate what all of this would look like without acceleration and with the acceleration, revealing that that extra velocity definitely seems to come from the photon pressure coming from the stars, creating the extra push for all of this gas. We usually refer to this as radiation pressure. And that's basically how things like, for example, solar sails generally work as well. And so some of these stranger structures that have been discovered are very likely produced as a result of this extra pressure from the light itself. But not everything can be explained here just yet. One obvious mystery is the shape itself. For some reason, one of the sides is stretched out, producing what the scientists refer to as a squircle. In other words, it's not perfectly circular and it's not perfectly spherical, but why, nobody knows just yet. It's probably not just from the stellar wind and probably not from the pressure from the starlight. Something else has to be happening here, something that we're probably going to be discussing in some of the future videos. Nobody knows yet. Okay, next picture is a picture of two unusual galaxies. A galaxy pair known as VV191. Although in this case this is a combination of infrared light from James Webb and the visible and ultraviolet light from the Hubble telescope. This is one of those investigations where the scientists are trying to figure out how various galaxies are formed around the universe. But in this case, this is also a kind of a forced perspective, meaning that these two galaxies, even though they look like they're close, they're actually farther apart from one another, and so they're not interacting and are not disturbing one another either. With one of the galaxies, in this case the left one, being elliptical, and one being a spiral galaxy like the Milky Way. But in this case, it's just how they're positioned toward us that makes this image incredibly beautiful. In case you're wondering, the spiral galaxy on the right is much closer to us, and so here the scientists are trying to investigate how some of the light coming from the left changes as it passes some of the interstellar dust through the galaxy on the right. But intriguingly, by accident, they've discovered that there are also some other additional really exciting observations here that you're probably familiar with already. Gravitational lensing effects. The elliptical galaxy on the left has just enough mass to essentially form a gravitational lens of some of the galaxies behind it. And this will allow the scientists in the future to determine exactly how much mass it possesses and to find out if it's hiding any other mysteries, including figuring out the total mass of the mysterious dark matter. Although in this image you can also see some of the other intriguing, really far away galaxies, with some being slightly lensed as well. But because the study is not out yet, for now we just get the image. A very beautiful image, but we don't really know what the scientists are going to find here just yet. Then we got this other really exciting observation from an extremely far away part of the observable universe. The observation of an extremely far away and also extremely bright and very active quasar, and not just any quasar but a red quasar. You might actually check out one of the older videos that explains the difference between these types of quasars. It should be in the description below. But in this case, a very unusual quasar that's about 11.5 billion years old and seems to be surrounded by a cluster of interacting, fast-moving galaxies. And in this case, massive galaxies in the process of formation around this unusual active quasar. And this object is one of the most powerful known galactic nuclei that produces some of the brightest light from this distance. Which of course implies that all of this is produced by an extremely massive, possibly gigantic black hole with an enormous accretion disk that produces these very bright jets. But in this case, a lot of this emission is also caused by a very powerful galactic wind. The wind that's so ridiculous that it very likely completely shuts down the activity inside the galaxy itself, and also pushes out most of the gas out of the host galaxy, very likely completely stopping the activity here. This process is usually known as quenching. Yet despite this very powerful quenching, there seem to be at least a few galaxies orbiting around this galaxy, possibly also extremely close, and also at extremely high speeds, that seem to be actually creating stars very fast. You can see that some of the stuff here moves at approximately 700 km per second. But it's also an extremely dense environment that's right now very difficult to explain if we use some of the modern modeling when it comes to the formation of galaxies. So we don't really expect such an extremely dense and such an extremely active environment to be formed around these unusual quasars. Yet there are clearly at least 3 confirmed galaxies very close to each other, orbiting very fast, with all of this around a very powerful quasar that instead of quenching the star formation, seems to actually increase the production of stars here, making this a relatively big mystery. And because this was just discovered only a few days ago, at the moment we don't really know what's going on here or how to explain any of this. So I'm definitely going to be coming back and talking more about this because I'm actually super curious what the scientists find here. And then the last discovery coming from the James Webb is not as much a beautiful image as it is a discovery that can potentially help us understand what happens in centers of various galaxies. In this case, maybe helping us understand how galaxies evolve over time, but also potentially answering questions in regards to possibility of life in centers of these galaxies. It involves a class of organic molecules we refer to as PAH, polycyclic aromatic hydrocarbons, that are believed to be some of the most widely available organic molecules all over the outer space, discovered in a lot of different regions and even found on different asteroids, and generally are believed to have been responsible for the formation of more complex organic macromolecules. Or in other words, these are kind of like the tiny blocks that we believe early life might have evolved from. And so the scientists have always been trying to find more of these in order to see if we can actually learn about how the life formed on planet Earth. But these compounds are also extremely bright in the infrared region, especially when there's a lot of starlight, and that allows the scientists to see them from really far away. And so very recently, James Webb was able to produce a relatively accurate map of the concentration of these molecules in the central regions of 3 very active galaxies. Once again, galaxies with very powerful black holes in the middle that usually produce a lot of radiation that we generally believe would most likely destroy most chances for any organic molecule or complex molecule to form, and thus very likely prevent life from forming as well. And so the original assumption was that active galaxies, at least in their center, will usually not have a lot of these PAH molecules because they would generally be destroyed by the activity from the black hole. But instead, the analysis showed that some of them can definitely survive, even in the regions where there's a lot of energy that should technically break them apart, turning them into much simpler molecules. In this case, the scientists think that maybe a lot of these molecules were just protected by huge amounts of gas that's already present in these regions. Moreover, the effects from the supermassive black hole is definitely visible here as well. It looks like charged pH molecules, or much smaller ones, might have actually been destroyed completely, and only larger neutral molecules survive the emissions from these black holes. Now, to the scientists, this might imply several things. For one, it makes it slightly more difficult to try to predict and to try to map the centers of these active galaxies. In the past, because pH molecules are so easily visible in the infrared, that's what the scientists generally used to map these regions and the gas inside them. But because the activity from the black hole changes them quite dramatically, this does create several limitations. At the same time, it does imply that a lot of organic molecules would most likely disappear from the center of these galaxies, with only a fraction of more complex molecules left in the process. Now, because we think that these molecules are responsible for the formation of life, this once again means that these active galaxies very likely destroy almost everything, including the possibility for any organic life to form, with only some limited chance in some of these more dense regions. But even here, things would be very different from what we have here in the Milky Way, because the Milky Way galaxy has never really gone through these extremely powerful and very active stages that would completely transform the chemistry of the entire galaxy. In the Milky Way galaxy, we find a huge variety of these pH molecules, and thus the chance for organic life here is much higher. But the implications from this study are still not obviously clear. Since the scientists expected to find nothing here, yet they found some pH molecules, this will probably require more investigations in the future. Hello wonderful person, this is Anton, and it's time for more updates from the James Webb Space Telescope. It's only been a few months, but so many new discoveries have already been made, and so many incredible pictures have already come out. Such as the picture we discussed last time, the iconic Pillars of Creation, that has now been also released using the mid-infrared observations as well, helping us uncover even more detail that some of the future studies are going to be discussing. But this was discussed in the last video, you can find in the description. Today we're going to be talking about several other discoveries, some really surprising discoveries, coming from a lot of other observations as well. And let's start with one of the most incredible pictures of the last week. The beautiful image that you see right here, unusual hourglass shape created by a newly forming star right in the middle. Okay, technically it's hourglass shape if you turn it this way. And what's interesting is that this is only visible in the infrared light. This was completely invisible to us using Hubble telescope or using a lot of other telescopes as well. And what this shows us is a protostar known as L1527, a star located approximately 430 light years away from planet Earth in the region we refer to as the Taurus molecular cloud. And in this case, this is also kind of showing us what our own sun might have looked like 4.5 billion years ago, because this is literally a formation of a typical star. A very young star that's actually hidden by a huge amount of rotating gas, with some of this gas then being ejected from the star itself and colliding with surrounding matter. Although in this case, the scientists also color these particular parts a little bit differently, depending on the density as well. The blue part shows us relatively low density, whereas the orange parts show us the gas that's more dense. But the disk itself, the protoplanetary disk, that's actually relatively similar size to the solar system, is right there in the middle. And at the moment, this is not actually a star yet. It's not really burning hydrogen yet, which means that it hasn't started its nuclear reaction. But once it does, it's most likely going to expel most of this dust, leaving behind a typical protoplanetary disk. But this was a star that was observed relatively close to us. There was another interesting discovery from much farther away. The first ever red giant star discovered at billions of light years away from us. And this is of course something our sun is going to become as well, sometime in the next few billions of years. So basically a star like Betelgeuse or a star like Antares, a star that's hundreds or even thousands of times larger than our sun, but is much cooler, with a temperature of approximately 3,000 to 4,000 Kelvin. A star visible in this image right here that the scientists nicknamed Globular, and quite clearly visible right there. And this particular red supergiant is most likely between 7 and 40 solar masses, and is probably extremely similar to what Betelgeuse is today. But because these stars generally don't actually last very long, in some sense the scientists got super lucky in being able to see this, because as always this is a result of a gravitational lensing effect. In this case, a lensing effect produced by a massive galactic cluster known as El Gordo, with the cluster magnifying the star by approximately 4,000 times. And this particular star seems to have existed during the most productive period of star production in the universe. Approximately 3.1 billion years after the formation of the universe, that's when the star formation was at its highest peak, and there were probably quite a lot of these red giants going around. But when it comes to stars, this is still obviously not the farthest object. A few years ago we've discussed the discovery of the star known as Icarus, which back then was the record holder, but now the record holder is once again from the James Webb, the star known as Arendelle. This one existed in the universe when it was only about 900 million years old, with the light from the star traveling for nearly 13 billion years. But all of these other stars discovered so far were basically extremely bright blue stars, which is one of the reasons why we're able to see them so well. This, however, is the only red giant discovered so far, and because we know so much about red giants from observing them in the Milky Way, this will definitely allow the scientists to investigate what these early galaxies were like, and how the stars might have differed back then compared to how they are today. And then on top of this, James Webb discovered so many new galaxies and provided a lot of information about other galaxies we've already known about. For example, this galaxy right here. This was actually discovered back in 2012, approximately 10 years ago, and back then the Hubble telescope allowed us to see this. This was essentially the candidate for the farthest galaxy ever found. The redshift here was approximately 11, and so the scientists who originally discovered this galaxy wanted to actually try to take a look at it with the James Webb telescope in order to discover more detail and, more importantly, potentially find out what's happening in this galaxy, because it appeared a little bit different because of the coloration that you see. It seems to be both orange and a little bit of red. So something else was going on here, but it wasn't really clear because, as you can see, this was the limit of the resolution. And so now exactly the same image is available with the James Webb, and it's able to see something else happening in this region. This dot by itself seems to actually contain two dots inside of it. Moreover, this is a galaxy that's actually gravitationally lensed into 3 separate images, which means that the scientists get to see it 3 times from 3 separate angles. And this shows us that there are indeed 2 separate objects. One seems to be a little bit more blue, and one seems to be a little bit more red, with the blue object essentially being an active galaxy with a lot of young star formation and practically no dust, and the object that's more red being another galaxy that's slightly older and contains a lot more dust. But in a nutshell, these are 2 separate galaxies that seem to be on a collision course. Essentially, this is the observation of the first ever galactic merger. Or at least it seems so. It's still not entirely clear what's happening here, because even with the James Webb, the images are somewhat low in resolution. But all of this will probably be resolved in some of the future studies. Additionally, there was another study that recently confirmed the observations that we've discussed a few months ago of essentially some of the most distant galaxies discovered in just the first few weeks of operation of the James Webb. You can see these 2 galaxies here, with the redshift of 10.5 and 12.5, with the farthest galaxy confirmed so far being known as Glass Z12. This is when the universe was only about 350 million years old, and these galaxies, surprisingly, are actually very active. They also seem to possess a symmetrical, spherical or disc-like shape, but also just a tiny percentage of the size of the Milky Way. More importantly though, it does appear like they actually formed extremely fast, suggesting that most galaxies in the universe very likely already existed within about 100 million years once the universe began. But then we also had some additional observations in the mid-infrared frequencies, discovering even more galaxies when the universe was only about 1 billion years old. The galaxies that were never seen before. And in this case, these galaxies were extremely well visible, and visible in the period of the universe that the scientists really want to learn more about. The period that happened right after the so-called Dark Ages, when the universe reionized through the formation of various stars and various galaxies. And so essentially they were able to see the galaxies right at the end of that Dark Ages period. Which means that MIRI instrument on the James Webb opens up an entire new way for us to investigate the reionization period of the universe. All of the galaxies here are extremely well visible and will present an opportunity for a lot of investigations in the future. Nothing major was discovered here just yet, this was just a proof of concept, but it's an important step in trying to solve a lot of these mysteries of the early universe. But there has been at least one discovery coming from a nearby galaxy that's actually kind of intriguing and somewhat unusual. The galaxy that you sort of see right here. This is known as WLM, or Wolf-Lonnemark-Melotte dwarf galaxy, located approximately 3 million light years away from us, just a little bit farther away than the Andromeda galaxy. But what's intriguing about this galaxy is that it's also in a region where there's really nothing else there. In other words, unlike other galaxies that usually have partners, or basically orbit one another, WLM dwarf galaxy is essentially completely by itself. But more importantly, the recent analysis using James Webb determined something really important about it. It seems that this galaxy has never actually interacted with anything. It's never experienced any collisions, it's never really experienced being next to another galaxy, and it seems to have always been completely by itself. And so the most recent observations from the James Webb Telescope were able to see through pretty much all of this, discovering quite a lot of detail about the stars, the gas, and more importantly, the composition of pretty much everything in this galaxy. In the process of discovering that, first of all, it seems to be really light in elements heavier than hydrogen and helium, which means that those elements must have disappeared a long time ago, with the current explanation being that a lot of supernovae that happened here before very likely just pushed all of the gas away from the galaxy, throwing most of the heavier elements to the outskirts and into the intergalactic space. The scientists usually refer to this as the galactic wind, and it has been previously observed in other smaller galaxies. With the stars that are left here, especially low-mass stars, responsible for most of the light coming from this galaxy, also being particularly interesting because these are really ancient stars, with some of them potentially existing for billions of years or even almost since the beginning of the universe. And because this galaxy has never interacted with anything, it can actually help the scientists answer quite a lot of questions about the galactic evolution and the evolution of stars by analyzing this somewhat extreme example. An example where most of the matter on most of the stars have never actually experienced any kind of interaction with outside forces, which to some extent is also almost the opposite of the other images James Webb has been taking for several weeks now, such as this one right here. This is an image of two intertwined galaxies 270 million light years away from us that are literally colliding and creating huge amounts of stars, approximately 20 times as fast as the Milky Way galaxy. This is an object known as IC 1623. And in this case, it's one of those examinations we've discussed before, where both the Hubble telescope and the James Webb are trying to take a look at various types of interacting galaxies in order to learn more about star formation and in order to understand exactly how galactic evolution works or how galaxies ended up like they are today. And so in this case, the combination of the studies of these interacting galaxies with whatever else we can find here will actually help the scientists possibly answer these questions in the next few years. For now though, it's just a really beautiful image. But not the only image of an active galaxy with a lot of star formation and a lot of energy. There was also an examination of a Seyfert galaxy, a galaxy with an active center known as NGC 7469. And in this case, the scientists investigated the interaction between the galactic nucleus, which is active and essentially contains an extremely active black hole in the middle, and also various star-forming regions located in the galaxy itself. And because this galaxy is also sort of facing us, it becomes possible to analyze this with a lot of precision. And because the scientists were able to peer through most of the gas in this galaxy using infrared frequencies, they were now able to see huge amounts of winds coming from the supermassive black hole heating up a lot of gas surrounding the region around the black hole through the process known as shock heating. As this black hole in the galactic center pushes on all of the gas surrounding it and creates a kind of a shock that spreads throughout the galaxy. And though usually this ends up stopping star formation, it can actually also create a lot of compressed regions of gas that end up encouraging star formation in certain regions, which is probably what's happening in this galaxy as well. It does contain several star-forming regions, where large parts of this galaxy have now become essentially starburst regions, the regions with a lot of stars being born right now. And all of this a result of the activity from the central black hole that's dumping huge amounts of energy into the interstellar medium. Although a lot of this could also be a product of a collision with the second galaxy you see right there. In other words, the activity from the black hole could have been influenced by the interaction with the partner galaxy. Hello wonderful person, this is Anton, and today we're going to be discussing some of the propositions behind the idea of search for extraterrestrial life. And specifically some of the new studies that even suggest on how we could maybe use the James Webb Telescope to look for potential extraterrestrial intelligence. With some other studies suggesting on how we could maybe even look for this across vast distances of space, proposing several techniques. And so let's discuss this in a little bit more detail, but let's start with the definition of what we're actually talking about. Here the idea is referred to as the technosignatures, or the signatures of various types of extraterrestrial technology that could be somehow visible and also detectable by looking at various features on those distant planets, with Dyson Sphere being the best known potential technosignature. And so obviously by detecting a certain signature from one of the stars or one of the planets somewhere out there, it would maybe help us answer the famous Fermi paradox: where is everybody? And in the last few years, a lot of different scientists, including NASA scientists, have made quite a lot of different propositions on how we could maybe look for these technosignatures using modern technology, with a lot of these ideas combined into a single paper that you can find in the description below, focusing specifically on various opinions and various ideas from various experts in the field, with different ideas looking for different signatures across different distances. And actually distance here is really important, mostly because it's obviously a lot easier to see if there is some kind of a star structure as opposed to a simple planetary structure or even planetary formation that could indicate alien technology. And all of this is of course for one simple reason. Even today there's still no clear understanding if first of all life is common across the universe, and if second of all intelligent life is common. So there's still no clear understanding if we're just very unique and very special living here on planet Earth, or if the other life is somewhere out there as well and we're just not seeing it yet. As a matter of fact, it's a very important question to answer because it will define our understanding of what's happening here on the planet. But in the last 30 years or so, it's actually become kind of difficult to study all of this, mostly because various telescopes, including the iconic Arecibo telescope, have actually stopped searching for extraterrestrial life or extraterrestrial intelligence. Although in the last few years, there have been a lot of new push from different agencies, including NASA and a lot of NASA scientists, trying to restart this particular program and trying to see if we can find something after all. Although, spoiler alert, the last paper from SETI, Search for Extraterrestrial Intelligence, that was conducted using the Murchison-Whitefield array in Australia, unfortunately discovered nothing on the frequencies of about 150 MHz. With this particular study being the fourth such attempt to find something, and in a different frequency. And in this case, it once again sort of confirms that, well, it doesn't seem like there are a lot of radio signals coming from anywhere in our galaxy, and that by itself is already a mystery. Why not? On top of this, there's obviously been a lot of talk about life, extraterrestrial life, a little bit closer to home, for example on Venus or on Mars. And it's already been suggested that we might be able to discover something a little bit sooner on, for example, Venus, specifically in the atmosphere of Venus. Now that by itself would be a big discovery, and it would definitely help us understand what's potentially happening on other objects. But discovering biological simple life is not really the same. However, there's also been suggestions from other scientists that, well, maybe we're going to be able to find something hiding in a solar system that was actually sent here thousands if not millions of years ago. For example, some sort of an ancient probe from one of the alien species that might have passed really close to our solar system a long time ago, and decided to place some kind of a probe just to scan the system to see if it was habitable enough. Now this is obviously one of the possible places we can look for these so-called technosignatures, but that's also something that we cannot do right now, mostly because we don't even know what we're looking for. Obviously things like machine learning or artificial intelligence can help us go through a lot of data and potentially discover something, but what exactly are we going to be looking for in the solar system? Maybe it's something that's composed of something very specific, or maybe it's something in a very specific orbit. But what? And so to try to help us with this, one of the studies you can find in the description sort of came up with a bit of a framework based on a concept known as the ichnoscale, which can be described as a kind of a footprint given away by a certain technosignature depending on the distance, with some technosignatures being a lot more visible than others. For example, here they propose that any major mega project should be actually visible even from across the galaxy, or maybe even in a neighboring galaxy. So if there is some kind of a Type 3 civilization building something extremely large, it would be relatively easy to find. Obviously, since we haven't really found anything yet, chances are it probably doesn't exist. Then we have things like Dyson spheres that should be detectable from roughly around 3,000 light years away from planet Earth, so most of the stars within that vicinity, if there are any Dyson spheres or Dyson rings around them, would most likely produce enough emissions for us to be able to see them with modern telescopes. But as of today, nothing has been definitively found yet. All of the previous detections did not have all of the necessary signatures, for example, the requirements for the infrared emissions that are expected from these unusual objects. On the other hand, if there is a planet somewhere out there that possesses what's known as the exoring, specifically something that's known as the Clark exobelt, and that's essentially when you have a lot of communication satellites in a very specific orbit, this also can be visible from approximately 3,000 light years away from us. But if this particular alien species uses something more discrete like lasers for communication, this can even be visible from hundreds of thousands of light years away from us. So some things could be detected much easier. Once again, so far nothing has been found. But then we also come to some other more exciting things like, for example, seeing the night lights, or in this case, city lights. This is something that could be maybe visible from about 30 light years away from us, but it would definitively tell us or show us that something out there is definitely different from other planets. The same kind of goes for relatively weak radio signals. If there's a planet somewhere out there that has a lot of radio emissions, a lot of, for example, TV shows of their own, we could only detect this from approximately 30 light years away from us. So unless these emissions are pointed directly at us, they're going to be extremely difficult to find at farther away distances. And then we have this other proposition that also connects to this other study, the study that connects all of this to the capabilities of James Webb Space Telescope. In theory, we should also be able to detect pollution, alien pollution, and in this paper they even establish what kind of pollution would be easiest to detect and would definitively tell us that this is extraterrestrial intelligence and not something natural. So what is it? Well, first you have to understand one thing. When we're looking at these stars and these planets, this is kind of what the scientists are going to be looking at. And somewhere in these pixels, an extremely minute change is going to indicate that there is very likely some sort of a planet here. And in that change, the scientists are going to have to look at the exact parameters of light that was detected, essentially looking at the wavelengths of light that came from this particular object. This will allow the scientists to actually, possibly, see through the atmosphere of this planet. So, for example, here, if we look at the planet in the TRAPPIST-1 system, right here at the edge of the planet, the star's light is passing through the atmosphere and is being absorbed or potentially changed in some way by the molecules in the atmosphere itself. That tiny detection is all the scientists are going to have and all they're going to be working with. And in this case, several different studies have already suggested what we could maybe see coming from these distant planets using the James Webb Telescope. So for example, if there is a sudden detection of what's known as the red edge, which refers to the sudden drop that you see right here around the color red, and is actually caused by the absorption of light in this particular spectrum by something equivalent to chlorophyll. In this case, this would indicate that maybe there is some kind of a plant life or photosynthetic life on this particular planet, because that's exactly what we see from planet Earth, with this particular technique being used today to study the, for example, health of different forests or distribution of chlorophyll on our own planet. And so by detecting this edge elsewhere, it would be a pretty interesting sign that maybe there's life there as well. But that would obviously not be intelligent life, and so that's why the scientists recommend looking for pollutants or pollution in general. But the thing about pollution on Earth is that, well, some of it is naturally produced, or I mean, it kind of looks like pollution. So for example, obviously things like CO2 or even nitrogen oxide, which we generally consider to be pollutants, are also naturally produced by various events and various things on Earth. But there are some pollutants that cannot be naturally produced and have never been found in nature, with one pollutant being extremely interesting to science. The series of pollutants we refer to as CFCs, also known as chlorofluorocarbons. You might already know them because these are the pollutants that have created the so-called ozone hole. But they're also extremely powerful greenhouse gases, and so there's actually quite a big chance that if there is some kind of an extraterrestrial intelligence somewhere out there, it might be using these particular chemicals for their own use. And detecting them would be potentially possible with James Webb Telescope by looking at an extremely specific frequency. It would look very similar to that red edge I mentioned before, but would produce observations that would potentially look like this, with the wavelength resembling this right here for just one of these chlorofluorocarbons. And so detecting this around some kind of a distant planet would be an extremely interesting sign and would be very difficult to explain in a non-technological way. It would suggest to us that somewhere out there there's probably another alien species that is having same troubles with the pollution, potentially their own version of the ozone hole, or maybe they're using it for, well, basically warming up, because it's a greenhouse gas. But unfortunately in this case it would only work with dimmer stars, such as a typical red dwarf or M-type star. It would not work with stars like our Sun because they're just too bright, and it would most likely produce a lot of other observations that can sort of wash out a lot of data. And so by focusing on stars like the TRAPPIST-1 system that already has 7 confirmed planets, or even the nearby Proxima Centauri, we could maybe detect something there. But unfortunately, when it comes to stars similar to our Sun, there is still no good proposition or good idea. But anyway, these are still extremely interesting studies, and once the James Webb Telescope becomes operational, it'll be very interesting to see what the scientists do discover. Although for now, I guess I'm going to still stick to my opinion that, well, it looks like we kind of might be sort of alone. It does look like there is just nothing going on around us and no one is trying to talk to us. And also maybe, just maybe, intelligence is extremely rare. And we'll discuss this in one of the future videos because I'm going to be making this into a kind of a mini-series in regards to search for extraterrestrial intelligence. So one of the questions a lot of us have been asking since the launch of James Webb Telescope is, how exactly is it going to handle the collisions with various micrometeorites, especially because it's going to be staying in space without any ability to repair this telescope for several years and very likely up to several decades, or at least 1 decade. In other words, the question is, what happens when one of the micrometeorites strikes the mirrors or hits some other essential part of the telescope? Is the mission going to be over? Well, obviously the answer to that question is no, but there is a more specific answer to this that we're going to be talking about in this video because, as you might have heard already, it just happened. A slightly larger than average micrometeorite officially hit one of the main mirrors on the telescope. But what you might have not heard yet is that this is not the first time it happened since the launch. This is actually the 5th time it happened, and the first 4 collisions were not really that major. And so in this video I wanted to talk a little bit more about the details behind what happened, what all of this means, and more importantly, what we know about these micro collisions or micrometeorite collisions from the previous important missions such as Hubble, which, as you can probably imagine, received so many more collisions over the period of about 30 years. And this is exactly where we're going to start. The iconic Hubble telescope. The telescope that changed everything. And you might already be aware that in the beginning, when the Hubble just started operating, NASA performed several so-called Hubble servicing missions in order to replace some of the parts on the telescope that were either aging or were outdated or maybe even broken. And as they were doing so, they actually ended up bringing some of the parts back to planet Earth to be studied in more detail. And even in the first few years of its existence, when the space around the planet was not really that crowded yet, Hubble has already accumulated quite a lot of different impact craters from various collisions. So for example, in 1993, approximately 3 years after the original launch, the solar panels here had to be replaced because of the unusual temperature fluctuation they were causing to the telescope. And the fun fact is that the solar panels were the contribution from the European Space Agency and were actually then returned to the ESA for further study once they were retrieved from the Hubble telescope. And this was actually the first opportunity in history of space exploration to see the kind of impacts that would occur on any spacecraft after about 2 years orbiting planet Earth. And here they found hundreds of impact craters on just a small section of the solar array. Some of them were extremely tiny, only microns in size, but some of them were relatively large, approximately several millimeters. Then, 9 years later, solar panels were replaced yet again, returned to planet Earth, and once again, even more impact craters were found here as well. This particular solar panel is actually on the display in the Netherlands, inside the ESA's technology center known as ESTEC. But in this case, the scientists also wanted to find out where exactly the impact craters came from. Was it from micrometeorites? Was it from some kind of a human-made debris? Or was it from something else entirely? In other words, they also decided to conduct a chemical analysis on every single one of these collisions. And they did so by looking at whatever was unusual present inside the impact craters that should not have been there and that probably came from something else. And so for a lot of these impact craters, the fragments inside were from micrometeorites. It was because of things like iron and nickel. But some of them also contained aluminium and oxygen, which very likely came from human activity, essentially from various solid rocket motors or from various space debris. And considering the amount of debris that's orbiting the planet, it should not really come as a surprise. And here the team even went as far as matching the shape and size of various craters to actual models of rockets that were responsible for producing the debris. But obviously, even after 30 years of the collisions here, the Hubble telescope is still operating and still producing all of the imagery we have today. In other words, the scientists have definitively established that these collisions, these micrometeorites, even though they do cause occasional problems, are not going to be causing any major faults in the telescope or are going to be the reason for the mission failure. Although they do cause a kind of a gradual degradation in the amount of power the solar panels can provide, and also the gradual declination in the quality of images, but in this case some of this can be actually restored with software. Although interestingly enough, in the last decade or so, the amount of debris has obviously increased dramatically, and the chance for collision has gone from approximately 0.15% chance per year to approximately 0.3% per day, increasing by about 700 times. Okay, but that's collisions on the Hubble telescope. What about James Webb? I mean, we know that the solar panels should be okay over time, but how about the other parts, the shield or the telescope mirrors, which in this case are directly exposed to open space? Well, first of all, we have to remember that because this particular telescope is not orbiting the planet but is actually in the Lagrange 2 point, it's pretty far away from any human-made debris, and because of this, the chance of a collision here is pretty low overall. On top of this, in this region, it's also not going to be receiving a lot of micrometeorites, which usually tend to approach planet Earth, simply because it's the largest gravitational body in this area. But more importantly, these mirrors were specifically designed to withstand impacts from some of the smaller micrometeoroids. Although over time, it's very likely that the appearance of these mirrors is going to become a little bit more rough, reducing in the overall reflectivity and also becoming a little bit more rugged as well. But for the first few years, all of these imperfections can be easily corrected digitally, and also because when the mirrors were originally designed, they were created to be even smoother than they should have been. In other words, the actual telescope does not have to be as perfect as it currently is. It can still operate even if the mirrors are slightly scratched. And so today, the models suggest that it will probably take at least a few years before any of this becomes a significant problem. And since the original launch a few months ago, there have already been 4 smaller measurable micrometeoroid strikes, with all of them directly meeting the expectations and the mathematical models. However, the most recent 5th collision was a little bit larger than the predictions and the original assumptions. And so because of this, the scientists behind the mission have to crunch a few numbers and develop future techniques for when this happens again. At the moment though, this is definitely not a problem and is not going to cause any issues for future observations. And so in this case, the mission is still a go, and it's still going to be performing way beyond our expectations. And the recent measurements just from a few days ago suggested that all of the components on the telescope are still performing way beyond expectations, and technically even exceed the original expectations the scientists had for this mission. And since the telescope has already been in space for, I guess, half a year, receiving only 5 collisions is actually good news. It means that maybe these will be a lot less common than the scientists thought. There's actually a really good article by NASA that you can find in the description below that sort of goes through very common questions about the resiliency of this telescope and how likely the mirrors are to survive a lot of different types of collisions from various micrometeorites. With the scientists here even explaining different techniques that were used to test the mirrors and how everything on the telescope was engineered to withstand a lot of different types of damage and a lot of bombardment from various objects. And one of the ways that all of this will be done in the future when there's a lot of damage on the telescope is going to be by adjusting the position of certain segments and thus cancelling out the portion of distortions coming from the damaged parts. In other words, there's a physical way in which the scientists are going to be able to try to counteract the damage to certain mirrors. And this has already been done for the recently damaged segment known as C3. And when it comes to more dramatic events such as meteor showers, the team in this case can also prevent the further damage by conducting certain protective maneuvers. So for example, by turning the optics away from known meteor showers before they occur. Although the most recent collision was not from a meteor shower, it was one of those events that just happens by chance. And one of the other things that the scientists are hoping to learn from all of this is actually in regards to these collisions. By keeping the James Webb Telescope in this position for several years, it sort of turns the telescope into a kind of a highly sensitive detector of various micrometeorites, which can also help us learn a little bit more about the micrometeorite condition in these environments and also teach us a little bit more about the collisions as we become interplanetary species and as we start launching missions to, for example, Mars. And so it will definitely help the scientists measure the overall effect of micrometeorite collisions for various other objects and various other telescopes, especially in the region known as the Lagrange 2 point, something that has never really been measured before by previous missions. And so at least for now, that's kind of all we know. We know that the James Webb seems to be operating normally, we know that it's going to be releasing its first images on July 12th, and we also know that the mission seems to be a go and nothing seems to be broken and will probably stay normal for many years to come. In this case, the entire telescope was definitely engineered and designed to withstand a lot of different damage. Over the past 2 decades, the International Space Station has taught us one important lesson. Collisions with micrometeorites are completely unavoidable and happen all the time. And we've discussed some of the bigger ones, here on the channel, even as recent as just a few months ago. Which is exactly why, when the scientists were planning the James Webb Telescope mission, they've anticipated the amount of various collisions the telescope is going to be receiving over the next few years. And so the original designs of the telescope anticipated a lot of the changes over time and the degradation in the quality of the images because of the collision with various tiny pieces of rock, various micrometeorites. But what the scientists did not anticipate is a slightly larger in size micrometeorite that actually did collide with a mirror only a few months ago. Hello wonderful person, this is Anton, and today we're going to be discussing yet another part from the report that was recently published, and that as always you can find in the description below, that goes through some of the more detailed analysis on the somewhat unexpected effects the recent collision had on the main mirror. In other words, even though the scientists anticipated at least one collision per month that's slowly going to degrade the mirror over time, this right here seems to be an outlier, and it's a much bigger outlier than anyone predicted. And so let's discuss this in more detail, talk a little bit more about the facts about these collisions, and what the scientists are going to be doing in the future to prevent this from happening. So first of all, we know that this particular collision did not really affect the telescope that much. These images that were recently received, the images we discussed on the channel several times now, were essentially produced after this collision, which implies that the telescope still functions as intended and is going to be working as intended for many months and many years to come. We also know that since the original launch a few months ago, the telescope has already received at least 19 tiny collisions from various micrometeorites smaller than a grain of sand in size, with 6 of them leaving marks behind which are slowly causing the effects on the telescope, but not dramatic enough to change anything for the next few years. Nevertheless, it means that at least once a month there's going to be one collision somewhere on a telescope. Very likely similar to what you see right here, leaving just a small mark behind, but over time this might actually start adding up. And so if the mission lasts for at least 10 years, we can expect at least 100 of these collisions, and very likely a lot more. But when the NASA engineers were building the telescope, they've conducted very thorough tests on the mirrors, even hitting them with various samples, simulating various collisions from micrometeorites. In other words, these collisions were expected, and the telescope was tested before it was even launched. On top of this, the design itself involves materials that generally withstand extreme pressures and temperatures really well. For example, the individual pieces of the mirror are actually made out of beryllium, a very light and a very strong material that's usually used in aviation for various supersonic flights and has even been used in space shuttles, with the rest of the mirror designed and polished so extremely well that the telescope actually has accuracy much higher than needed for the actual mission. Or in other words, it was designed to actually be a little bit more accurate than it needs to be. And so over time, even if the micrometeorites degrade the quality and the accuracy of the mirror itself, it's still going to be producing really good images because the engineers in this case kind of over-designed it. And so until that major collision that happened a few months ago, none of the other collisions affected anything. But between May 22nd and May 24th, there was a very unexpected and somewhat large collision in a segment known as C3. A collision that seems to have affected the performance way more than anyone expected. And in this report we even get the actual numbers and the actual visual representation of what all of this means. So in terms of the accuracy of the mirrors, the performance of the telescope is measured by the amount of various deformations from all of the starlight hitting the telescope, with the smoothness of the mirror being responsible for the accuracy. So if the mirror is extremely smooth, as it was originally, the amount of deformation of the light is only going to be in like 5 to maybe 10 nanometers in size, which is just a little bit thicker than the thickness of the DNA molecule. And so when this mission began, the level of wavefront error was approximately 56 nanometers. You can kind of see that some of the mirror segments had a slightly larger error, but the majority were more or less the same. But following the impact on May 22nd to May 24th, the error jumped up by about 5 times. Right after the impact, it was approximately 258 nanometers, which was much higher than anticipated even after years of operation. But because we have 18 mirrors, it is possible for the scientists to average all of this out, and it's also possible to move each of these segments individually, readjusting and averaging out the overall errors. And so following a major readjustment, they were able to reduce the error in the C3 mirror down to 178 nanometers, but still approximately 3 times higher than it was before. And unfortunately, this also decreased the overall capability of the telescope by a tiny amount. Right now they believe that the average error has increased to approximately 59 nanometers, which is about 10 nanometers above the previous average that the telescope was experiencing. Which is of course why it was possible to produce all of these beautiful images, and why the telescope is still going to be functioning for many years to come. But there is of course a small concern here. The concern in regards to this particular impact. Because of the size of the particle and the speed with which it was moving, it's currently completely unexplained. Based on previous statistical analysis, nobody expected such a large piece to ever affect the telescope, especially so early on. And since James Webb is orbiting pretty far away from anything, and we don't really expect a lot of fragments or a lot of pieces of micrometeorites in this region, it adds a little bit to the mystery of what exactly caused this, and also raises a few questions about this particular environment and where all of these fragments are coming from. For all we know, maybe these Lagrange points, the stable points of orbit in the solar system, tend to capture other stuff, such as micrometeorites, which can then maybe collide with various missions that are also in this region. Or maybe there is a population of an unusually large micrometeorites that we never really knew about or never knew existed, and some of them might actually be in this region as well. And since the previous collisions with smaller objects have only decreased the overall error by about 1 nanometer, the fact that this one collision managed to take this mirror all the way to 250 nanometers of error is definitely completely unexpected. And so the question now is, well, was it just an unlucky event? Or is this something that's going to happen again? And if it happens again, it means that the scientists will need to recalculate the overall number of collisions we usually expect for various interplanetary missions. That of course also includes a potential Martian mission, which might even have astronauts on board. In other words, this is actually really important for any potential crewed mission that might one day visit other planets. Which also means that the James Webb Telescope has officially now acquired a new mission, measuring the number of impacts of larger pieces in this particular region. Chances are that even after a few of these collisions, it's still going to function and it's still going to be producing beautiful images, but calculating the number of these collisions and more importantly, figuring out if this is going to be a problem for other missions, that's of course something that the scientists did not really anticipate originally. But despite all of this, the observatory is still working fine. As a matter of fact, it's working better than expected. With this report even mentioning that there were actually 344 different points of failure that were anticipated by the engineers and the scientists, with most no longer being an issue, with the majority of the problems related to various instruments. But chances are, even if one of the instruments fails, the mission is not going to stop. As a matter of fact, the telescope includes a lot of redundancy and can actually operate even if the majority of the instruments and the majority of the parts fail for one reason or another. So yeah, this mission has been designed pretty well. Which is a bit of a contrast with the original Hubble telescope launch, which created a bit of an embarrassment for NASA, because for the first few months, the telescope was unable to produce clear images. This was a bit of a failure. James Webb, on the other hand, is almost the opposite. And so really the only issue the scientists have faced so far is this unusually large collision, which nobody anticipated. And so because of this, the scientists are now planning for the telescope to avoid these during future passages through, for example, various micrometeorite dust fields that often cause meteor showers on a planet. And so during that time, the scientists think they can actually turn the mirror itself, pointing it sideways toward the direction of movement, in order to avoid future damage or direct hits from various micrometeorites. But for now, for the next few months, nothing major like this is going to be conducted, and the scientists are just going to wait and see if maybe, just maybe, this particular collision was just an anomaly. It might never happen again, and the telescope might only receive the expected one collision per month. A tiny collision that's only going to decrease the overall sensitivity by just 1 nanometer. But I'm sure we'll have more updates before the end of the year, and so I'm going to be following this up with another video sometime soon. Subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and support the channel on Patreon by joining channel membership or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.